Have you ever just lain in bed in the absolute dead of night and truly felt the weight of your own body pressing down into the mattress? It is a sensation so familiar, so constant, that we almost never stop to think about it. You feel your shoulders sinking into the softness. You feel the heavy anchor of your hips. You feel the backs of your heels making contact with the fabric of your sheets. It feels like a hug. It feels like safety. It feels like home. But what if I told you that this sensation, this feeling of heaviness that has grounded you every single second of your life, is actually one of the greatest lies in the universe? What if I told you that the force pulling you down, the force holding the oceans in their basins and the moon in the sky, might not be what you think it is? We call it gravity. We give it a name, and we think that by naming it, we understand it. But when we zoom in, past the skin of your body, past the cells, past the molecules, and down into the quantum realm of atoms and subatomic particles, gravity vanishes. It simply disappears. The equations that describe the rest of reality, the light hitting your eyes, the electricity in your brain, the atoms that make up the air you breathe, those equations have no room for gravity. This is the great ghost of physics. We are living in a universe where the most obvious thing we feel is the one thing we cannot explain. We are anchored to a rock spinning at 1,000 miles per hour, whirling around a nuclear furnace at 67,000 miles per hour, and yet we feel perfectly still, held in place by a ghost. Tonight, I want to take you on a journey into that ghost. I want to peel back the layers of reality and ask the question that keeps physicists awake at night. What is gravity actually made of? Is it a curve? Is it a particle? Or is it something else entirely, something so strange that our brains are not yet wired to comprehend it? Hello, my friend. I am Walter, the explorer. I am so glad you have chosen to pause your day and drift with me into the mysteries of the cosmos. It is a big universe out there, and it is much better to explore it together than alone. I noticed something interesting recently. 73% of the fellow travelers who listen to these stories have not yet subscribed to the channel. If you find peace or wonder in these journeys, please consider subscribing. It helps us keep the ship flying, and it ensures you never miss a trip into the unknown. Now, let us return to the weight pressing you into your bed. Let us go back to that sensation of weight. Close your eyes for a moment and really focus on it. That pressure you feel against your back is not just a passive thing. It is an active interaction between you and the entire planet Earth. Beneath you, below the floorboards of your room, below the foundation of your building, below the soil and the rock, there is a planet with a mass of roughly 13 septillion pounds. That is a number so large it becomes meaningless. It is a 1 followed by 24 zeros. 13 septillion pounds of iron, nickel, silicon, and oxygen, all gathered together in a sphere, all pulling on you. Every single atom in the earth is reaching out across the empty space and tugging on every single atom in your body. The iron in the earth's core is calling to the iron in your blood. The calcium in the ancient rocks deep underground is pulling on the calcium in your bones. You are being summoned. You are being held. And this pull is what we call weight. It feels strong, does it not? It feels undeniable. If you try to jump, you are immediately dragged back down. If you drop a glass, it shatters against the floor. Gravity seems like the ruler of our world, the inevitable dictator of motion. But here is where the mystery begins. Here is where the paradox opens up its mouth to swallow us. Gravity is actually pitifully weak. It is shockingly impossibly weak. Think about a small fridge magnet. You have probably played with one. You put it near a paperclip and the paperclip jumps up to meet it. Think about what just happened there. The entire Earth, all 13 septillion pounds of it, with all its mountains, oceans, and iron core, is pulling that paperclip down. The Earth is trying with all its might to keep that paperclip on the table. And yet, a tiny piece of magnetized metal, no bigger than a coin, is able to defeat the entire planet. The magnetic force from that little button is strong enough to snap the paperclip up, overcoming the gravity of the entire world. That is how weak gravity is. In the language of physics, the electromagnetic force, the force that governs magnets and electricity and light, is 10 to the power of 36 times stronger than gravity. That is a 1 followed by 36 zeros. To put that in perspective, if gravity were a single grain of sand, the electromagnetic force would be more sand than exists on all the beaches of a billion Earths. It is a disparity so vast that it breaks our ability to compare them. And yet, gravity wins. Gravity dominates the large-scale structure of the universe. Why? Because gravity has a secret weapon. It is persistent. It only works one way. It only attracts. Electromagnetism can attract, but it can also repel. Positive charges push away other positive charges. North poles push away north poles. In the grand mix of the universe, these pushes and pulls tend to cancel each other out. But gravity never pushes. Gravity only pulls. It accumulates. It builds. One atom pulls a little. 2 atoms pull a little more. A cloud of gas pulls itself together. A star pulls planets into orbit. A galaxy pulls billions of stars into a spiral. Gravity is the patient builder of the cosmos, the silent architect that shapes the void. But what is it? If you could look at gravity under a microscope, what would you see? This is the question that leads us to the edge of our knowledge. In the world of quantum physics, forces are not just magic invisible fields. They are made of things. They are made of particles. When a magnet pulls a paperclip, it is not magic. The magnet and the paperclip are exchanging tiny particles called photons. These photons are the messengers of the electromagnetic force. They fly back and forth, telling the paperclip to move. We know this. We have proven this. We can detect these photons. We have built our entire modern civilization on understanding how these particles work. Your phone, your computer, the lights in your room, they all work because we understand the quantum particles of electromagnetism. We also know about the strong nuclear force, which holds the centers of atoms together. It has its own messenger particles called gluons. We know about the weak nuclear force, which causes radioactive decay. It has particles called W and Z bosons. So, the logic of the universe seems clear. Forces are made of particles. Therefore, gravity should be made of particles too. Physicists even have a name for this theoretical particle. They call it the graviton. It is a beautiful name, isn't it? It sounds ancient and futuristic at the same time. The graviton, the messenger of weight, the carrier of the pull. If gravitons exist, they are flying around you right now. Trillions of them would be streaming from the earth, passing through your mattress, passing through your body, grabbing onto your atoms and telling them to move downward. You would be swimming in a sea of gravitons, a constant invisible rain connecting you to the planet. It is a lovely picture. It makes sense. It fits the pattern. But there is a problem. A massive, glaring, terrifying problem. We have never found a graviton. We have smashed atoms together at nearly the speed of light in the Large Hadron Collider. We have built detectors deep underground in abandoned mines to shield them from cosmic rays. We have listened to the sky with giant dishes. We have found the Higgs boson. We have found the neutrino. We have found quarks. But we have never, ever seen a graviton. It is as if nature is playing a trick on us. We can feel gravity. We can measure it. We can predict the motion of the planets with exquisite precision. We can land a robot on Mars by calculating exactly how gravity will pull it. But when we try to touch the stuff gravity is made of, our hands grasp at empty air. It is a force without a face, a ghost without a body. And it gets worse. When we try to use the mathematics of quantum mechanics to describe gravity, the equations explode. They do not just fail. They give us answers that are impossible. They give us infinities. They tell us that the energy of a gravitational field at the smallest scales should be infinite. They tell us that space and time should be tearing themselves apart. The math breaks. The logic crumbles. This is the great divide in physics. On one side we have quantum mechanics, the rule book for the tiny, the grainy, the pixelated world of atoms. On the other side, we have general relativity, Albert Einstein's masterpiece, the rule book for the huge, the smooth, the heavy world of stars and galaxies. Both theories are incredibly successful. Both have been proven right in thousands of experiments. But they hate each other. They speak different languages. They cannot be in the same room together without starting a fight. And you, lying in your bed, are the battleground. Your body is made of atoms, which obey quantum mechanics. But your body is held down by gravity, which obeys general relativity. You're living proof that these two theories must somehow work together. You are a quantum object caught in a relativistic field. You are a mystery. So, let us try to imagine what might be happening if we cannot find the graviton. Maybe we need to change how we think about space itself. Einstein taught us that gravity is not really a force at all. He said it is a curvature. Imagine your mattress again. If you put a heavy bowling ball in the middle of your bed, the mattress curves down. If you then roll a marble across the bed, it will curve toward the bowling ball. The marble is not being pulled by a force. It is just following the curve of the mattress. Einstein said, space-time is like that mattress. The Earth bends space around it, and you are just sliding down the slope of that bent space. It is a beautiful, elegant idea. It explains so much. But it treats space as something smooth, like a sheet, like a fabric. Quantum mechanics says nothing is smooth. If you look closely enough at a sheet of metal, it is not smooth. It is a jagged landscape of atoms. If you look at a glass of water, it is not a continuous fluid. It is a chaotic crowd of molecules. Quantum mechanics says that everything, absolutely everything, is made of chunks, of quanta, of pixels. So, if space is a thing, and if gravity is the shape of space, then space itself must be made of chunks. Space itself must be pixelated. Imagine that. Imagine that the empty air in front of your face is not truly empty and continuous. Imagine that it is made of tiny, tiny grains of space, atoms of geometry. This is the territory we are entering. We are going to explore the idea that reality itself has a resolution limit, that if you zoomed in far enough, way past the atom, past the proton, past the quark, you would hit the bottom. You would see the grain of the universe. And maybe, just maybe, gravity is what happens when those grains rub against each other. As you lie there, feeling the weight of your body, imagine that you are not just resting on a mattress. Imagine that you are resting on a frothing, bubbling, boiling ocean of quantum foam. The stillness of the night is an illusion. The solidity of the floor is an illusion. Even the empty space between the stars is alive with activity that we are only just beginning to suspect. We are going to travel to the smallest scales imaginable. We are going to shrink down until we are smaller than light itself. We are going to look for the graviton in the shadows of the math. We are going to ask if the universe is a hologram. We are going to ask if gravity is actually leaking in from another dimension. It is a journey that will take us to the edge of comprehension. But do not worry. We will take it slow. We will walk gently. The universe has waited 13.8 billion years for us to ask these questions. It can wait a little longer for us to find the answers. For now, just feel the weight. Feel the mystery pressing you down. Feel the invisible hand of the cosmos holding you safe. And remember, that feeling of heaviness is the feeling of connection. It is the feeling of belonging to a planet, to a system, to a reality that is far stranger and more beautiful than we ever dared to dream. Have you ever run your fingertips across a perfectly smooth sheet of glass? Maybe it was the screen of your phone before it gathered the dust of the day. Or perhaps a window pane on a winter morning, cold and flawless against your skin. It feels continuous, doesn't it? It feels unbroken. Your finger glides without interruption, without a single bump or snag. To your senses, that glass is a solid, singular thing, a perfect plane of existence. It feels like peace. It feels like certainty. But you know, deep down, that this smoothness is a lie. If we were to shrink you down, smaller than a dust mite, smaller than a bacterium, that smooth glass would transform into a jagged, chaotic landscape. You would see mountain ranges of silica molecules. You would see canyons of empty space. You would see a world that is not smooth at all, but rough, granular, and built of distinct, individual blocks. The smoothness is just an illusion created by distance. It is a trick played on your mind by the limitations of your touch. Now, hold that image in your mind, the smooth glass that is actually a jagged mountain range, because this is exactly the problem with gravity. This is the heart of the war that has been raging in physics for 100 years. We have two maps of reality, and they are trying to describe the same territory, but one map says the world is smooth glass, and the other says it is a pile of jagged rocks. And until we figure out which one is true at the bottom of everything, we cannot truly understand the universe. On one side, we have the magnificent, elegant theory of general relativity. This is Albert Einstein's masterpiece. When Einstein looked at gravity, he did not see particles or pixels. He saw a fabric. He saw a smooth, continuous sheet that he called space-time. In Einstein's world, space is not made of stuff. It is a geometry. It is a stage. And this stage is flexible. It can bend. It can stretch. It can ripple like the surface of a pond. When a massive star sits in space, it is like placing a heavy sleeping person in the middle of a trampoline. The fabric curves down under their weight. That curve is gravity. It is a beautiful, smooth, continuous slope. You can slide down it. You can orbit around it. Nowhere in Einstein's equations does the fabric rip or tear. Nowhere does it become pixelated. You can zoom in on Einstein's space-time forever, and it will always remain smooth, gentle, and continuous. It is a theory of infinite smoothness. This theory is perfect for describing the dance of galaxies. It explains how black holes bend light. It explains how the universe expands. It is the theory of the vast. It is the theory of the everywhere, and it works. Every time we test it, Einstein is right. But then we have the other map, the map of the tiny, the map of the quantum. Quantum mechanics looks at the universe and screams that nothing is smooth, absolutely nothing. Energy is not a continuous flow. It comes in packets called quanta. Light is not a continuous wave. It is a rain of photons. Matter is not a solid block. It is a swarm of buzzing, popping, jumping particles. In the quantum world, everything is pixelated. Everything has a resolution limit. If you zoom in on a beam of light, you eventually see the individual photons. If you zoom in on a piece of gold, you eventually see the individual atoms. Quantum mechanics is the theory of the granular. It is the theory of the chunks. And it also works. Every time we test it, it is right. Your computer, your lasers, your nuclear power plants, they all prove that the universe is made of chunks. So here we are, drifting in the quiet of the night, caught between two perfect theories that contradict each other. Einstein says space is smooth. Quantum mechanics says everything is chunky. They cannot both be right. If gravity is the shape of space and space is smooth, then gravity cannot be a particle. But if all forces are made of particles, then gravity must be a particle, and space cannot be smooth. This is not just a philosophical disagreement. This is a mathematical disaster. When physicists try to combine these two theories, when they try to calculate how gravity works at the quantum scale, the equations produce nonsense. They predict that the gravitational force between two particles should be infinite. They predict that space should be curling up into tight knots of infinite energy. They predict that the universe should not exist, but you exist. You are here, breathing, listening, feeling the weight of your body. The universe has not exploded into infinite energy. The bed you are lying on has not collapsed into a black hole. So, nature knows the answer. Nature has found a way to knit the smooth and the chunky together. We just have not figured out the stitch pattern yet. Imagine for a moment that we could turn up the magnification on reality. Imagine we have a dial that lets us zoom in deeper and deeper into the fabric of the space right in front of your nose. We start by zooming past the dust, past the air molecules, past the atoms. We are now in the vast, empty cathedral of the atom, where electrons orbit the nucleus like distant planets. But we keep going. We zoom into the nucleus, past the protons and neutrons. We zoom into the quarks that make up the protons. We are now in a realm so small that light itself is too big to fit. We are in the subatomic, subnuclear dark. But we keep going. We keep turning the dial. We go deeper into the empty space between the quarks. What is down here? Is it just empty void? Is it just smooth nothingness? According to quantum mechanics, if we go down far enough, down to a scale called the Planck length, we will hit the bottom. The Planck length is the pixel size of the universe. It is the smallest possible distance that can exist. How small is it? It is hard to even find words for it. The Planck length is to an atom what an atom is to the entire visible universe. It is roughly 10 to the power of negative 35 meters. That is a decimal point, followed by 34 zeros, and then a 1. It is a scale so tiny that it makes a proton look like a galaxy. At this scale, the smooth fabric of space that Einstein imagined might actually be a frothing, boiling, chaotic storm. This is what physicists call the quantum foam. Imagine the surface of the ocean. From a high airplane, the ocean looks like a smooth, blue sheet. That is Einstein's view. But if you are in a small boat during a storm, the ocean is not smooth at all. It is waves, crashing and churning. It is foam and spray. It is chaos. That is the quantum view. Down at the Planck scale, space itself might be churning. It might be constantly ripping open and stitching itself back together. Wormholes might be forming and vanishing in a fraction of a second. Dimensions might be curling up and unfurling. Up here, in our big, slow world, we float on top of this foam like a ship on a calm sea. We feel the smooth average of the chaos below. We call that average geometry. We call it gravity. But down there, in the basement of reality, gravity might not be a curve at all. It might be the result of this constant, frantic knitting. It might be that space is not a thing that is, but a thing that is happening. Space might be an action. It might be a process. This idea changes everything. It means that you are not just occupying space. You are riding a wave of continuous creation. The space holding your body, the space filling your room, the space separating you from the moon, it is all alive with this quantum activity. It is humming with a secret energy that we can barely comprehend. And this brings us to a profound realization. If space is made of these tiny pixels or grains of geometry, then the universe has a limit to how much information it can hold. A smooth line can contain infinite points. A pixelated line can only contain a finite number of pixels. This means the universe is finite in its complexity. It means that, in a way, reality is digital. You are living in a universe that might be computed, not by a computer like the one on your desk, but by the fundamental laws of existence itself. Every moment of time, every inch of space, is a calculation. Gravity is the software running in the background, telling the pixels where to go. So, when you feel that heaviness in your limbs, when you feel the earth pulling you down, you are feeling the hum of that cosmic computer. You are feeling the collective result of deeper, hidden processes that are frantically working to keep you on the bed. You're being held by a mechanism so complex that our best minds are still struggling to glimpse its gears. But there is a gentleness in this chaos, isn't there? Despite all the violence of the quantum foam, despite the tearing and stitching of space at the smallest scales, up here in your room, everything is quiet. The storm at the bottom of the universe results in peace at the top. The chaos cancels itself out, leaving behind the stable, reliable, comforting pull of the earth. It is like the roar of a distant waterfall that merges into a soothing white noise. The universe is loud at the bottom, but it whispers to us at the top. And that whisper is gravity. It is the sound of the universe holding itself together. As we continue this journey, we are going to look at some of the wilder ideas about what these pixels of space might actually be. Are they tiny loops of string? Are they knots? Are they information? Some physicists believe that gravity is actually a hologram, that the three-dimensional world we see is just a projection from a flat, two-dimensional surface at the edge of the cosmos. Imagine that. Imagine that you, your bed, your room, and the stars outside are all a holographic projection, that the real you is smeared out across the edge of the universe, and what you feel as here is just a shadow of that distant reality. It sounds like science fiction, but it is one of the leading candidates for explaining what gravity really is. We will explore that holographic world. We will explore the idea that gravity might be leaking into our universe from a hidden fourth dimension. We will ask if gravity is even a fundamental force, or if it is just a side effect, like heat or pressure, an emergent phenomenon that only appears when you have enough stuff together. But for now, let the idea of the quantum foam settle in your mind. Visualize the space around you not as empty nothingness, but as a rich, thick, bubbling potential. You are not alone in the dark. You are surrounded by the most active, dynamic, and mysterious substance in existence. You are bathed in the quantum ocean, and you are safe. The ocean holds you. The foam supports you. The war between the smooth and the chunky does not tear you apart. It builds the stage on which you dream. The mystery is not a threat. It is a cradle. Take a deep breath. Let it out slowly. Feel the air moving in and out of your lungs. Even that air is made of atoms. And the space between those atoms is made of, well, we are still figuring that out. But whatever it is yours. It is your home. It is your universe. We have peeled back the first layer of the illusion. We have seen that the smooth face of gravity hides a pixelated heart. But what are the pixels made of? If we could grab one of those grains of space, what would it look like? Is it a tiny vibrating string of energy? Is it a loop of pure geometry? The journey is only just beginning. We are going to dive deeper. We are going to go smaller. We are going to look for the strings that tie the cosmos together. We are going to listen for the music of the spheres, played on instruments smaller than a proton. So, pull the covers up a little tighter. Let the weight of the blankets remind you of the mystery we are exploring. You are an explorer, lying in your ship, drifting through the strange and wonderful sea of space-time. And the current is carrying us forward toward the next great question. What if the fundamental building blocks of the universe are not points, but lines? What if everything, you, me, gravity, light, is just a symphony played on tiny, vibrating strings? Have you ever sat close enough to a cello or a double bass to feel the sound vibrating in your chest? It is a deep, resonant thrum that seems to bypass your ears and speak directly to your bones. When the musician draws the bow across the string, the air does not just move. It shivers. It comes alive. You can feel the tension in the wood, the friction of the horsehair, and the invisible waves of pressure expanding outward to fill the room. The note you hear, a low, mournful C perhaps, is not a static thing. It is a motion. It is a dance of energy. If you were to touch the string while it sang, it would tickle your fingertips. If you looked closely, you would see it blurring, occupying a space of uncertainty, existing in many places at once within the width of its vibration. Now, imagine that the entire universe is that cello. Imagine that the electron spinning in the atom of your fingernail is not a hard little ball of matter, but a note. Imagine that the photon of light striking your retina is not a bullet, but a chord. Imagine that gravity, that heavy, silent ghost pressing you into your mattress, is simply the deepest, longest, most pervasive song in the cosmic symphony. This is the vision of string theory. It is perhaps the most elegant, beautiful, and mind-bending idea in the history of physics. It suggests that if we could zoom in far past the atoms, past the protons, past the quarks, and even past the quantum foam we explored earlier, we would find that the fundamental building blocks of reality are not dots. They are tiny, vibrating filaments of energy. They are strings. Hello, my friend. It is Walter, the explorer, back again to guide you through the strange and beautiful architecture of our reality. I hope you are finding a comfortable rhythm in these stories, a place where your mind can rest while it wanders. I wanted to take a brief moment to ask you something. I have looked at our ship's manifest, and I see that 73% of the travelers listening to my voice right now have not yet subscribed to the channel. It is a small gesture, clicking that button, but it means the world to us. It helps us keep the engines running and the maps updated. If you are enjoying this journey into the impossible, please subscribe and join our crew of curious souls. It would be an honor to have you with us officially. Now, let us return to the music of the spheres. Let us think about why this idea of strings is so revolutionary. For thousands of years, ever since the ancient Greeks, we have thought of the world as being made of particles, little marbles, points. We imagined that if you cut a piece of cheese enough times, you would eventually get to a single, indivisible crumb of cheese. When we discovered atoms, we thought they were the marbles. Then we smashed atoms and found protons and electrons. We thought they were the marbles. Then we smashed protons and found quarks. We keep looking for the smallest dot, but there is a deep mathematical problem with dots. A point, by definition, has zero size. It has no height, no width, no depth. It is a mathematical abstraction. When physicists tried to calculate what happens when 2-point particles collide or interact gravitationally, the math went haywire. Because the particles are infinitely small, they can get infinitely close to each other. And when things get infinitely close, the forces between them become infinitely strong. The equations explode. They give us infinities, which is nature's way of saying, you have made a mistake. This is the disaster that happens when we try to combine gravity with quantum mechanics using point particles. The smooth gravity of Einstein cannot handle the infinite sharpness of a point. String theory solves this by smearing the point out. It says, stop thinking of an electron as a dot. Think of it as a tiny loop of string. It has a length. It is incredibly small, about 1,000,000,000,000,000,000 times smaller than an atom, but it is not zero. Because the string has a size, it cannot get infinitely close to another string. The interaction is spread out over the length of the string. It is softened. It is smeared. And just like that, the infinities disappear. The math calms down. The explosion of nonsense is replaced by a smooth, elegant interaction. But here is the truly magical part. In this theory, there is only one kind of ingredient. There is just the string. So, why does the universe look so diverse? Why is an electron different from a quark? Why is a photon of light different from a neutrino? Why is gold different from lead? In the old way of thinking, we had a zoo of different particles. We had an electron particle, a quark particle, a neutrino particle, and so on. It was messy. It was like having a soup with 100 different ingredients. String theory says there is only one ingredient, the string itself. The difference between particles is simply the way the string vibrates. Think of a guitar string. If you pluck it one way, it plays an A. If you hold it down and pluck it another way, it plays a C. It is the same string, made of the same material, but the vibration defines the note. In the universe, an electron is a string vibrating in electron mode. A quark is a string vibrating in quark mode. A photon is a string vibrating in light mode. And gravity? Gravity is just another vibration. The elusive graviton particle that we have been hunting for, the ghost that holds you to the earth, is simply a string vibrating in a specific closed-loop pattern. It is a loop of energy spinning and humming a tune that tells space to bend. This means that gravity is not separate from matter. It is not an outsider. It is part of the same orchestra. You, the bed you are lying on, the light in the room, and the gravity holding you down are all made of the exact same thing. You are all just different songs played on the same instrument. This unifies physics in a way that Einstein spent the last 30 years of his life trying to achieve. It brings everything under one roof. Gravity, electromagnetism, the nuclear forces, they are all just harmonies. The universe is literally music. It is a cosmic symphony of vibrating strings playing the song of existence. But there is a catch. There is always a catch when we peek behind the curtain of reality. For the math of string theory to work, for the strings to be able to vibrate in all the ways they need to create the particles we see, they need room to move. They need freedom. If you try to calculate the vibrations of these strings in our normal world, the math fails. It says the strings are too constrained. They cannot play the right notes. They are like a cellist trying to play in a telephone booth. They do not have enough elbow room to make the music of the universe work. The strings need more dimensions. We are used to 3 dimensions of space: left, right, up, down, and forward, backward. We can move in any of these 3 directions. Einstein added time as a 4th dimension. So, we live in a 4-dimensional world. But string theory comes along and says, no, that is not enough. The math of string theory demands that the universe must have 10 dimensions, or maybe 11. This sounds insane. You look around your room, you see the ceiling, up, the walls, left, right, and the distance to the door, forward, back. Where are the other 6 or 7 dimensions? How can we be living in a 10-dimensional universe if we can only see 3? Are they invisible? Are they ghost worlds? The answer string theory gives is fascinating. It suggests that the extra dimensions are not places you can go to, like Narnia or Wonderland. They are tiny, they are curled up, they are compacted. Imagine looking at a garden hose lying on the grass from far away. To you, it looks like a one-dimensional line. You can only move along it. But if you were an ant crawling on that hose, you would realize there is another dimension. You can walk around the circumference of the hose. The around dimension is real, but it is small and curled up. From a distance, you cannot see it. String theory says that every single point in space, the space right in front of your nose, the space inside your brain, the space between the stars, is like that garden hose. At every point, there are 6 extra dimensions curled up into a tiny, complex knot. These knots are so small that even atoms are gigantic compared to them. We cannot see them. We cannot move through them. But the strings can. The strings are small enough to feel these hidden dimensions. They wrap around them. They vibrate inside them. The shape of these tiny, invisible knots determines how the strings vibrate. And remember, the vibration determines what the particle is. So, the geometry of these hidden dimensions determines the laws of physics in our universe. If the knots were shaped differently, the electron might be heavier, gravity might be stronger, light might not exist. The fundamental rules of our reality are dictated by the shape of invisible geometry hidden at the smallest scales of space. These shapes have a name. They are called Calabi-Yau manifolds. It is a mouthful, I know, but imagine them as beautiful, multi-dimensional jewels. Imagine that space is not empty, but filled with a crystal lattice of these jewels. Every time you move your hand, you're passing through trillions upon trillions of these tiny, curled-up worlds. You are swimming through a sea of hidden geometry. And this brings us back to gravity. Why is gravity so weak? Remember the fridge magnet defeating the entire Earth? String theory offers a possible explanation, and it has to do with the shape of the strings themselves. In string theory, most particles, like the ones that make up your body and the light you see, are open strings. They are like snippets of thread with 2 loose ends. These loose ends are sticky. They stick to the fabric of our 3-dimensional universe. They are trapped here. The electrons in your body cannot leave our dimension. The light from your lamp cannot leave our dimension. They are stuck on the surface of our reality, like water droplets on a shower curtain. But the graviton, the particle of gravity, is different. The theory predicts that the graviton is a closed loop. It has no loose ends. It is a perfect circle of string. Because it has no sticky ends, it is not trapped. It is free to drift. It can float off the shower curtain. It can leak out of our 3-dimensional world and drift into the extra dimensions. This might be why gravity feels so weak to us. Maybe gravity is actually just as strong as the other forces, but most of it is leaking away. Most of the gravitational signal is drifting off into the hidden sixth dimensions, or perhaps even into other parallel universes entirely. We are only feeling the tiny fraction of gravity that remains in our slice of the cosmos. We are hearing the faint whisper of a shout that is echoing in a canyon we cannot see. It is a dizzying thought, isn't it? To think that the force holding you to the earth is actually a multi-dimensional traveler. To think that it explores realms of geometry that your mind cannot even picture. While you lie there, anchored by weight, that weight is a tether to a reality far vast and more complex than the room you see with your eyes. Close your eyes again. Picture the strings, tiny shimmering filaments of light, vibrating in the dark. They are everywhere. They are the air you breathe. They are the thoughts in your head. They are the darkness of the room. They are dancing in 10 dimensions, twisting and turning through shapes of impossible beauty. And the music they make is the universe itself. You are not made of solid matter. You are made of music. You are a collection of vibrations, a temporary harmony in the grand score of time. And gravity is the bass line that keeps the rhythm, the deep, resonant hum that holds the melody together. It is strange to think that we need 10 dimensions to explain the simple feeling of lying in bed. It seems excessive, but the universe is not concerned with what we think is simple. It is concerned with what works. And if it takes 10 dimensions of twisting, curling geometry to build a world where you can exist, then nature will build 10 dimensions. There is a profound humility in this perspective. We used to think we saw everything. We thought the world was just what we could touch and see. Now, we know that we are blind to most of reality. We are living on the surface of a deep, deep ocean, unaware of the currents moving beneath us. We are ants walking on a hose, unaware of the circle beneath our feet. But we are learning, we are listening, we are using the language of mathematics to feel our way into the dark. String theory is still unproven. We have not seen a string. We have not mapped the Calabi-Yau shapes. It might be wrong, but it is a beautiful, compelling map. It tells us that at the heart of everything there is harmony, there is vibration, there is a song. So, as you drift toward sleep, let the strings lull you. Imagine the vibrations slowing down, smoothing out. The frantic dance of the quantum foam calms into a gentle sway. The extra dimensions cradle you in their hidden folds. You are safe in the complex, elegant, musical arms of the cosmos. The ghost of gravity is not haunting you. It is singing you a lullaby. But if gravity can leak into other dimensions, what does that mean for us? Could we use gravity to send messages to other worlds? Could there be other universes right next to ours, hovering just a millimeter away in a fourth dimension, invisible to us but pulling on us with their gravity? Could dark matter be just the gravity of a ghost galaxy next door? We are going to venture even further now. We are going to leave the strings behind and step into the world of brains, giant floating membranes that drift in a higher dimensional bulk. We are going to ask if the Big Bang was actually the sound of 2 universes colliding. The night is long, and the universe is wide. Let us keep exploring. Imagine for a moment that you are a tiny 2-dimensional ant living on the surface of a vast shimmering shower curtain. To you, the universe is flat. You can walk forward, backward, left, and right. You can meet other ants. You can build cities. You can look at the patterns of light and shadow playing across the plastic surface of your world. but you have absolutely no concept of up or down. The air in the bathroom, the water droplets falling, the person singing in the shower, these things do not exist in your reality. They are outside your universe. They are in the bulk. Now, imagine that this shower curtain is floating in a dark, infinite room, and just a few inches away, parallel to your curtain, there is another shower curtain. It has its own ants, its own cities, its own light and shadow. You can never see them. You can never touch them. Light cannot travel through the empty air between the curtains. It can only travel along the surface of the plastic. So, to you, that other world is completely invisible. It is a ghost. But what if the curtain is heavy? What if it bends the air around it? What if, every once in a while, the two curtains drift close enough to touch? This is the dizzying reality of M theory. It is the big brother of string theory. While string theory gave us a universe made of tiny vibrating threads, M theory takes a deep breath and says, why stop at strings? If a string is a one-dimensional line, why can't we have two-dimensional sheets? Why can't we have three-dimensional blobs? Why can't we have multi-dimensional membranes floating in a higher dimensional space? In M theory, the fundamental objects of the universe are called brains. It is short for membranes. And you, my friend, might be living on one right now. Hello, brave traveler. It is Walter, the explorer, your guide through the folding geometries of the night. We have left the solid ground of the earth far behind. We have sailed past the atoms. We have swum through the quantum foam. And now we are drifting in the bulk, the vast empty hyperspace that might contain our entire universe, like a single bubble in a sea of foam. Before we dive into the physics of ghost universes, I want to gently remind you about our community. 73% of you are floating along with us without being subscribed. If these stories help you find a moment of peace in a chaotic world, please click that subscribe button. It tells the algorithm that we exist, and it helps us find other lost travelers in the dark. Now let us return to the shower curtain. The revolution of M theory happened in the 1990s. It was a moment of shock for physicists. They realized that the 5 different versions of string theory they had been working on were actually just different reflections of a single, deeper theory. And this deeper theory required not 10 dimensions, but 11 dimensions. That is the number that makes the math sing. In this 11-dimensional cathedral, strings can stretch out. They can become sheets. They can become D-brains. Think of a D-brain as a sticky surface for strings. Remember how we talked about open strings? The strings that make up light, photons. The strings that make up matter, electrons and quarks. They have 2 loose ends. In M theory, those loose ends must be attached to something. They are like the hairs on a piece of Velcro. They are stuck. They cannot leave the surface. This is why you cannot walk out of our universe. The atoms in your body are open strings, and their ends are pinned to the 3-dimensional brain we call home. Light is also made of open strings. This is a crucial point. It means that light is trapped on our brain. Light cannot travel into the extra dimensions. It cannot travel into the bulk. This is why we cannot see other dimensions. We can only see what is on our sheet of paper. We are trapped in a slice of reality, prisoners of our own electromagnetism. But remember the exception? Remember the rebel in the family of forces, gravity? The graviton is a closed loop of string. It has no loose ends. It has no Velcro hooks. It is smooth. It is slippery. It does not have to stick to the brain. It is free to wander. It can float off the surface of our universe and drift into the 11-dimensional bulk. This simple geometric fact that gravity is a closed loop changes everything. It explains why gravity is so pitifully weak compared to the other forces. Imagine you are shouting in a long hallway. Your voice carries a long way because the sound waves are trapped in the hallway. That is like electromagnetism. It is trapped on our brain, so it stays strong. Now, imagine you are shouting in an open field. The sound waves spread out in all directions, up, down, left, right. The energy dissipates quickly. The sound becomes faint. Gravity is shouting in an open field. It is not just spreading out through our 3 dimensions. It is leaking into the 7 extra dimensions of the bulk. We are only feeling a tiny fraction of its true strength. The gravity that holds you to your bed is just the leftover whisper of a force that is roaring in 11 dimensions. It is the spillage. It is the echo. But if gravity can leave our brain, can it also enter from somewhere else? This is where the hair on the back of your neck might stand up. If there is another brain floating nearby, another universe, millimeters away in the 4th dimension, we would not be able to see it. Our light cannot go there. Their light cannot come here. To our eyes, that space would look completely empty. It would look like a void. But gravity can travel between brains. If that other universe has stars, if it has galaxies, if it has massive black holes, their gravity would leak off their brain and travel through the bulk. It would cross the tiny gap and tug on our brain. We would feel it. We would feel a mysterious pull coming from empty space. We would see our own stars orbiting around nothing. We would see our own galaxies spinning faster than they should, driven by the ghost gravity of an invisible world. Does that sound familiar? It should. This is exactly what we see when we look at the universe. We call it dark matter. We look at a galaxy, and we see that it is spinning too fast. There is not enough visible matter to hold it together. It should fly apart. But something invisible is holding it. Something heavy. Something that does not shine. We invented the term dark matter to explain it, assuming it is some kind of invisible particle floating in our own universe. But what if it isn't? What if dark matter is not matter at all? What if it is the gravity of a neighbor? What if we are feeling the weight of a shadow galaxy on the other side of the dimensional veil? Imagine that. Imagine that right now, in the room with you, occupies the same 3-dimensional space, but separated by a slice of the 4th dimension. There is another world. Maybe it is a world of pure energy. Maybe it is a world of strange, exotic matter. Maybe it is a world just like ours, with another version of you lying in another version of a bed, wondering about the mystery of gravity. You are separated by a distance smaller than an atom, yet you can never touch. But your gravity touches. The weight of your body might be pulling on that other you. The weight of that other world might be anchoring ours. We are dancing a waltz with invisible partners, guided by the closed loops of gravitons passing through the dark. This concept, called brain cosmology, transforms our view of the cosmos from a lonely island into a crowded archipelago. We are not alone in the void. We are stacked like pages in a cosmic book. And sometimes the pages might slam together. Consider the Big Bang, the moment of creation, the singularity. We usually think of it as an explosion that happened out of nothing, a point of infinite density that just popped. But why? Why did it bang? Physics is silent on the why. But M-theory offers a spectacular, terrifying, and beautiful answer. It is called the ekpyrotic universe. The word comes from the ancient Greek for born of fire. The idea is that our universe was not created from nothing. It was created from a collision. Imagine two of these giant brains, these universe sheets, floating in the bulk. They are attracted to each other by gravity. They drift closer and closer and closer until crash. They collide. But this is not a car crash. This is a collision of entire realities. The energy of that impact is unfathomable. It is enough to vaporize everything that existed on the brains before. It is enough to fill the brains with a sea of hot, dense plasma. It is enough to expand space itself at the speed of light. To an observer inside the brain, it would look exactly like a Big Bang. It would look like the universe suddenly appeared in a flash of fire. But in this view, the Big Bang was not the beginning of time. It was just the latest clash. It was a moment of contact. And the expansion we see now, the galaxies flying apart, is the result of the brains bouncing off each other. They are drifting apart again, cooling down, quieting down. Life evolves. Stars form. You are born. You listen to a story about gravity. And eventually, billions or trillions of years from now, gravity will slow the brains down. It will pull them back together. They will stop drifting apart. They will reverse course. They will accelerate. And they will collide again. A new Big Bang, a new universe, a new cycle. This is the cyclic model of the cosmos. It suggests that time has no beginning and no end. It suggests that we are trapped in an eternal, breathing rhythm of creation and destruction. The universe is a lung, inhaling and exhaling. The universe is a heart, beating in the darkness of the bulk. The bang is just the heartbeat. How does that make you feel? Small, insignificant, or does it make you feel eternal? You are part of a process that never ends. The atoms in your body are the ashes of the last collision, and they will be the fuel for the next one. You are woven into the deepest fabric of existence. And all of this, the brains, the collisions, the parallel worlds, it all hangs on the nature of gravity. Gravity is the only thing that connects the cycles. It is the only thing that bridges the brains. It is the only witness to the full majesty of the 11-dimensional bulk. So, when you feel heavy, do not resent it. Do not wish to be weightless. That heaviness is your ticket to the multiverse. It is the proof that you are connected to the great mechanism. You are feeling the tug of the bulk. You are feeling the curve of the 11 dimensions. Let us try a visualization. Close your eyes and picture your body glowing with a soft, golden light. This light is trapped within you, trapped on our brain. It cannot leave. It illuminates your skin, your bed, your room. Now, picture a faint purple mist emanating from your center. This mist is gravity. It does not stop at your skin. It drifts through the mattress. It drifts through the floor. It drifts through the earth. But it also drifts out of reality. It drifts sideways, into a direction you cannot point to. It floats into the bulk. And there, in the dark, it mixes with the purple mist coming from other worlds. It mingles with the gravity of stars you will never see. It touches the gravity of beings you will never meet. In the bulk, we are all touching. In the bulk, there is no separation. The loneliness of our universe is an illusion of light. In the dark realm of gravity, the cosmos is a single, interconnected web. We are holding hands with the multiverse, even if we cannot see the fingers. But there is a stranger thought still. If gravity is a closed string, a loop, can we break it? Can we cut the loop and turn it into an open string? If we did, would it get stuck to our brain? Would we suddenly be able to manipulate gravity as easily as we manipulate light? Could we build engines that push against the bulk? And what about the other end of the scale? We have looked at the tiny strings. We have looked at the giant brains. But what happens to space itself when gravity gets too strong? What happens inside a black hole, where the curvature becomes infinite and the brain punctures? Some physicists believe that black holes are not just dead ends. They believe they are gateways. They believe that a black hole is a localized collision of brains, a tunnel to another sheet. Or perhaps a black hole is a hologram generator, storing the information of everything that falls into it on its surface, preserving the memory of the universe forever. We are drifting deeper now. The shower curtains are fading into the distance. We are floating in the pure, empty, 11-dimensional potential. It is quiet here. The noise of the parallel worlds is muffled. There is only the slow, rhythmic breathing of the bulk. You are safe here. You are a traveler of the mind, and the mind can go where the body cannot. Your body is stuck to the sticky paper of the earth, but your imagination is a closed string. It is free. It can loop and twist and explore the hidden geometries. Sleep is a kind of journey into the bulk, isn't it? You disconnect from the sensory world of light and touch. You drift into a private universe of dreams. Maybe, in sleep, we are remembering our multi-dimensional nature. Maybe we are visiting the neighbors. So, let go of the 3 dimensions. Let go of up and down. Let go of left and right. Let yourself float in the direction of elsewhere. The gravity you feel is the anchor that will bring you back in the morning. For now, you are free to roam. But the mystery deepens. If gravity is leaking, does that mean our universe is slowly evaporating? Is energy being lost to the bulk? And if so, is the bulk heating up? Is there an ecology of universes out there, competing for the energy of the strings? We are going to take one more step into the weird. We are going to ask if the universe is not just brain, but a holographic brain. We are going to explore the idea that you are not 3-dimensional at all, that you are a flat painting on the wall of the universe, and your feeling of depth is a trick of the light, the holographic principle. It sounds like something from a movie, but it is one of the most serious and debated ideas in theoretical physics. It suggests that the information that makes up you is plastered on the horizon of the cosmos, and you are just the projection. Are you ready to question your own depth? Are you ready to flatten yourself out to see the truth? The night is still young, and the dimensions are many. Have you ever held a soda can in your hand and rotated it slowly, reading the label? It is a cylindrical object, a 3-dimensional thing made of aluminum and liquid and gas. But the label, the paper or the paint wrapping around it, is just a 2-dimensional surface. It has height and circumference, but it has no depth to speak of. Yet, everything you need to know about the contents of that can is written on that flat surface. The ingredients, the nutritional value, the volume, the brand, the flavor. The information describing the 3-dimensional interior is completely encoded on the 2-dimensional boundary. You do not need to taste the soda to know it is there. You just need to read the label. Now imagine that the universe is just a very large, very complex soda can. Imagine that you, your bed, the room you're lying in, and the stars burning in the night sky are the soda. We feel 3-dimensional. We feel like we have depth. We can move forward and backward. We occupy volume. But what if we are just the contents? What if the real information, the fundamental data that describes who and what we are, is actually written on a distant 2-dimensional screen at the edge of the cosmos? What if our feeling of depth is just a holographic projection, a ghost image emerging from a flat reality billions of light years away? This is the holographic principle. It is one of the most startling, counterintuitive, and widely respected theories in modern physics. It suggests that gravity, that heavy, inescapable pull you feel right now, is not a force that lives inside the bulk of the universe. Instead, it is a projection. It is a geometric illusion created by the processing of information on a distant surface. You are not a solid body in a solid room. You are a three-dimensional image generated by a two-dimensional code. Hello, my fellow traveler. It is Walter, the explorer. We have journeyed far tonight, from the quantum foam to the vibrating strings, and now we stand at the edge of the holographic horizon. It is a strange place, but I promise you are safe here. Before we unfold the dimensions of this mystery, I have a small request. I see that 73% of the wonderful souls listening to this story are not yet subscribed to our channel. It is a simple click for you, but for us, it is the gravity that holds our little community together. If these stories help you sleep, or dream, or wonder, please subscribe. It helps us continue this voyage into the unknown. Now, let us return to that cosmic soda can. To understand why physicists believe the universe might be a hologram, we have to talk about the most extreme objects in existence: black holes. For a long time, we thought of black holes as cosmic vacuum cleaners, monsters that swallowed everything and destroyed it. We thought that if you threw a book into a black hole, the information in that book, the story, the characters, the words, was gone forever, erased from the universe. But in the 1970s, a brilliant physicist named Stephen Hawking realized something profound. He discovered that black holes are not truly black. They glow. They emit a faint, cold radiation, now called Hawking radiation. This means that black holes slowly lose energy. They shrink. Over billions upon billions of years, they evaporate and disappear. This created a paradox that threatened to destroy all of physics. If a black hole evaporates, what happens to the stuff that fell inside? If you threw a diary into a black hole and then the black hole disappeared, where did the diary go? Quantum mechanics has a strict rule. Information is never destroyed. It can be scrambled, burned, or shredded, but in principle, you can always put it back together. If a black hole destroys information, then quantum mechanics is wrong. And if quantum mechanics is wrong, then our understanding of reality collapses. The solution to this paradox came from two giants of physics, Gerard 't Hooft and Leonard Susskind. They proposed something radical. They said that when an object falls into a black hole, it does not just disappear into the center. They argued that the information about that object, its atomic structure, its spin, its mass, gets plastered onto the surface of the black hole. The surface of a black hole is called the event horizon. It is the point of no return. Susskind and 't Hooft suggested that the event horizon acts like a giant hard drive. When an elephant falls into a black hole, the three-dimensional elephant is seemingly lost. But a two-dimensional copy of the elephant's data is scrambled and stored on the horizon, like a sticker on a bumper. The information is preserved. It is not destroyed. It is just translated from 3D to 2D. This means the entropy, the amount of disorder or information, of a black hole is not determined by its volume, how much space is inside, but by its surface area, how much skin it has. This was a shock. In our normal world, if you want to know how much information a room can hold, you look at its volume. You can stack books from floor to ceiling. But for a black hole, the books can only be stored on the walls. The interior volume does not matter. Only the surface area counts. And here is where the leap happens. If this is true for black holes, if the 3D interior is perfectly described by the 2D surface, then why shouldn't it be true for the entire universe? We live in a universe that has a horizon, the edge of the observable cosmos. Maybe, just maybe, everything inside this horizon is just a projection of the data stored on that edge. Imagine a cinema screen. The screen is flat. It is two-dimensional. But when the movie plays, you see depth. You see characters moving forward and backward. You see landscapes that stretch to the horizon. You get lost in the story and forget that you're looking at a flat sheet of white fabric. The depth is an illusion created by the light and the pattern of the images. The holographic principle says the universe is that movie. The screen is the boundary of the cosmos. The pixels on that screen are incredibly tiny units of information, bits, ones and zeros, encoded at the Planck scale. And the light that projects the movie, that is the interaction of quantum entanglement. The physics happening on the boundary creates the sensation of gravity happening in the bulk. This is not just a wild guess. In 1997, a physicist named Juan Maldacena discovered a mathematical Rosetta Stone. He found a specific type of universe, a toy universe, mathematically speaking, where this holographic connection is exact. He showed that a theory of gravity inside a volume is mathematically identical to a theory of quantum particles living on the surface of that volume. They are the same theory, written in two different languages. In the boundary language, there is no gravity. There are just particles interacting. But in the interior language, gravity emerges. It pops into existence. Gravity, in this view, is not a fundamental force. It is a translation. It is what happens when you read the label of the soda can and imagine the soda. So, bring your attention back to your body. Feel your weight. According to the holographic principle, that weight is a holographic shadow. The real you, the fundamental data that makes up your atoms and your consciousness, is smeared out across the distant horizon of the universe. You are physically located at the edge of all things, but your data is projected inward, creating the avatar that is lying in bed right now. The gravity you feel is the result of the information processing happening on that distant screen. When you move your arm, the bits on the horizon shift and rearrange. When you fall asleep, the pattern of data on the edge of the cosmos settles into a new configuration. You are a puppet, and the strings are made of information stretching across billions of light years. Does this make you feel less real? It shouldn't. In fact, it makes you incredibly vast. It means you are not confined to the small space of your bedroom. Your fundamental nature is as large as the universe itself. You are wrapped around the cosmos. The boundary of the universe is your skin. And this idea explains why gravity is so weak. If gravity is just a projection, a side effect of information, then it makes sense that it would be thinner than the other forces. A hologram is always a bit ghostly compared to the source. The electromagnetic force, the light, the atoms, might be the ink on the screen. Gravity is just the image that floats in the air. This also changes our relationship with space. We tend to think of space as a container, an empty box that we sit inside. But if the universe is a hologram, space is not a container. Space is a product. Space is generated. As the information on the horizon becomes more complex, as the quantum bits entangle with each other more deeply, they knit space together. Think of a video game. The world inside the game, the mountains, the castles, the sky, does not exist until the computer processes the code. The code generates the space. If you turn off the computer, the space vanishes. The holographic principle suggests that space-time is the video game. The quantum information on the horizon is the code. And gravity? Gravity is the game engine. It is the set of rules that tells the pixels how to simulate a 3D world. It is a lot to take in. It challenges everything our senses tell us. We feel solid. We feel deep. We do not feel like flat data. But our senses evolved to help us survive on the African savanna, not to understand the deep architecture of the cosmos. Our senses tell us the earth is flat, but we know it is round. Our senses tell us the sun moves around the earth, but we know the opposite is true. Our senses tell us we are 3D, but physics is whispering that we might be 2D. There is a strange comfort in this. It means that the separation between things might be an illusion too. In a hologram, every part of the film contains the image of the whole object. If you cut a holographic film in half, you do not get half the image. You get the whole image, just a little fuzzier. The information is distributed. It is everywhere at once. If the universe is a hologram, then the information that makes up you is entangled with the information that makes up everything else. On the distant horizon, your bits and the bits of the star Betelgeuse and the bits of a grain of sand on Mars are all mingled together. There is no here and there on the horizon. There is just one vast interconnected web of data. Separation is a trick of the projection. Distance is a feature of the hologram, not the source. Deep down at the level of the code, we are all sitting in the same place. We are all written on the same page. So, as you lie in the dark, imagine the walls of your room melting away. Imagine the sky opening up. Visualize the edge of the universe, a shimmering sphere of pure information, glowing with the binary code of existence. See your own life, your own memories, your own body written there in patterns of light. And then see the projection beam, the invisible, silent laser of gravity, shining inward, creating the experience of you in this moment. You are a story being told by the horizon. You are a song being sung by the edge of the world. And gravity is the melody that carries you. But if space is just a projection and gravity is just a side effect, does that mean gravity isn't real? Is it an illusion? Or is it something else? Is it emergent, like heat? Think about heat for a second. You know what heat feels like. It feels real. It can burn you. It can warm you. But if you look at a single atom, it is not hot. It is not cold. It just has speed. Heat is what happens when you have a lot of atoms moving together. Heat emerges from the chaos. It is a collective behavior. Some physicists, like Eric Verlinde, believe gravity is exactly like heat. They call it entropic gravity. They say gravity is not a fundamental force of nature. It is not a graviton. It is not a string. It is not a curve. It is simply the universe trying to maximize its disorder. It is the inevitable tendency of things to drift together, because that is statistically more likely in a holographic universe. This would mean that gravity is not a thing at all. It is a statistical inevitability. It is the entropy of the universe pushing you down. You are being held to the earth not by a pull, but by the sheer probability of information. We are going to explore this idea of emergent gravity next. We are going to ask if the universe is made of information. Does it have a resolution limit? Are we living in a simulation? And if gravity is just entropy, does that mean it will eventually stop working? The night is deep and the questions are endless. But that is why we are here, to wonder, to drift, to feel the strangeness of being alive. Rest your mind on the horizon. Let your thoughts flatten out. You do not need to be deep tonight. You just need to be. The hologram will hold you. The code will keep you safe. The projection will not flicker. You are a perfect image, a masterpiece of data, a ghost with weight. And the story continues. Have you ever wrapped your hands around a warm mug of tea on a cold winter morning? Close your eyes and recall that sensation. You feel the heat radiating from the ceramic, seeping into your palms, thawing the stiffness in your fingers. It feels like a living thing, doesn't it? It feels like a substance, a fluid energy flowing from the tea into you. For centuries, scientists actually believed heat was exactly that, an invisible fluid called caloric that flowed from hot objects to cold ones. It made perfect intuitive sense. You could feel it flow. You could watch it spread. It felt fundamental, real, and undeniable. But we know now that this feeling is an illusion. If you were to shrink down to the size of an atom and swim inside that mug of tea, you would not find a single particle of heat. You would not find a caloric fluid. You would only find water molecules vibrating furiously, crashing into each other like dancers in a chaotic mosh pit. Heat is not a thing. It is a statistic. It is the average speed of those crashing molecules. When you touch the mug, the fast-moving molecules of the ceramic strike the slow-moving molecules of your skin, transferring their momentum. The sensation of warmth is just the microscopic violence of collisions translated by your brain into a feeling of comfort. Heat is an emergent property. It only exists when you zoom out. It is a side effect of the crowd. Now, hold that thought. The idea that something as real and physical as heat is actually just a statistical side effect, and apply it to the force holding you to your bed right now. What if gravity is exactly the same? What if the pull of the earth is not a fundamental force of nature? What if there is no graviton particle? What if there is no curving sheet of space-time? What if gravity is just the heat of the universe? What if it is simply what happens when the information of the cosmos tries to rearrange itself? This is the radical, mind-bending proposal of entropic gravity. It suggests that gravity is not a cause, but a consequence. It suggests that you are not being pulled down by a force, but pushed down by the statistical inevitability of the universe trying to maximize its disorder. You are falling because it is the most probable thing for you to do. Hello, my fellow explorer. It is Walter, the explorer, back to guide you through the shifting sands of theoretical physics. We are wading into deep waters tonight, questioning the very reality of the force that keeps our feet on the ground. Before we dive into the entropy of the void, I want to take a brief moment to speak to the 73% of you who are traveling with us, but haven't yet joined the crew officially. If these nightly journeys into the impossible help you find wonder or peace, please consider subscribing to the channel. It is a small click for you, but it acts like a powerful entropic force for us, bringing our community together and helping us reach more souls looking for a quiet place in the cosmos. Thank you for being here. Now, let us return to the mystery of the warm mug. To understand entropic gravity, we have to talk about something that sounds messy, but is actually the driving engine of time itself. Entropy. You have probably heard the word. People usually use it to mean disorder or chaos. If you leave your room uncleaned, it gets messy. That is entropy. If you break an egg, it splatters. That is entropy. But in physics, entropy is something much more precise. It is a measure of information. Specifically, it is a measure of hidden information. Think of a messy room with clothes thrown all over the floor. There are a million different ways the clothes could be scattered and still look messy. You could move a sock 3 inches to the left, and the room would still look like a mess. The state of the room, messy, has high entropy because there are many, many ways to arrange the details to achieve it. Now, think of a perfectly clean room with every shirt folded and stacked. There is only one way to achieve that state. If you move a sock, the order is broken. The clean state has low entropy because it is very specific. Nature loves high entropy. Nature loves options. If you let a system alone, it will always drift toward the state that has the most possible configurations. This is the second law of thermodynamics. It is why heat flows from hot to cold. It is why gas expands to fill a room. It is not because a force is pushing the gas. It is simply because there are more ways for the gas to be spread out than for it to be clumped in a corner. The gas spreads out because it is statistically overwhelmingly likely to do so. Now, here comes the genius of a Dutch physicist named Erik Verlinde. In 2010, he published a paper that shook the foundations of physics. He asked, "Is gravity just the universe trying to increase its entropy?" Think about a rubber band. When you stretch a rubber band, you feel a force pulling back. It wants to snap back to its relaxed shape. Why? Is there a rubber force inside the atoms? No. It is entropy. When the rubber band is relaxed, the long polymer chains inside it are coiled up and tangled. There are billions of ways for the chains to be coiled. It is a high entropy state. When you stretch the rubber band, you force those chains to straighten out. You create order. You lower the entropy. The force you feel pulling back is not a fundamental attraction. It is an entropic force. It is the statistical tendency of the polymer chains to want to return to their messy, coiled, high entropy state. The rubber band pulls because it wants to be messy again. Verlinde suggested that gravity is the rubber band of the cosmos. Remember the holographic principle we talked about? The idea that the information of the universe is stored on distant screens or horizons. Verlinde combined this with thermodynamics. He proposed that when you move a mass like a star or a planet or your body, you change the information on the holographic screen. You disrupt the entropy. When you lift an object away from the Earth, you are stretching the rubber band of space-time. You are reducing the entropy of the holographic surface. Nature hates this. Nature wants to maximize entropy. So, the universe exerts a force to pull the object back down. That force is what we call gravity. According to this view, gravity is not a fundamental interaction between particles. It is the result of the universe's tendency to disorder. You fall toward the Earth because falling increases the entropy of the system. You fall because the universe wants to scramble the information on the horizon. This is a profound shift in perspective. It means gravity is not written into the source code of the universe. It is an emergent behavior, like a traffic jam. A traffic jam is a real thing. You can see it. You can be stuck in it. But you cannot find a traffic jam particle inside the engine of a car. The jam emerges from the interactions of many cars. Gravity emerges from the interactions of quantum information. If Verlinde is right, it solves one of the biggest headaches in physics: why gravity is so weak. We discussed earlier how a fridge magnet can defeat the entire Earth. In entropic gravity, this makes perfect sense. Electromagnetism is a fundamental force. It is direct and powerful. Gravity is just a statistical side effect. It is a leftover influence. It is weak because it is not really a force at all. It is just a tendency. It also explains why we cannot find the graviton. We have been hunting for the particle of gravity for decades, smashing atoms and building giant detectors with zero success. If gravity is entropic, there is no graviton. Searching for a graviton would be like searching for a phonon of sound in a silent room, or looking for a particle of pressure without the gas. We are looking for something that does not exist at the fundamental level. Imagine the implications for our journey. We started by looking for a particle. Then we looked for a curved sheet. Then we looked for strings. Now we are looking at pure information. We are seeing the universe not as a machine made of parts, but as a cloud of data seeking equilibrium. This idea connects beautifully with the sensation of heat we started with. We know that black holes have temperature. Stephen Hawking proved that. And in thermodynamics, temperature is related to the motion of particles. Verlinde showed that the formula for gravity looks suspiciously like the formulas for thermodynamics. The acceleration you feel due to gravity is related to the temperature of the holographic screen. So, in a very poetic sense, gravity is the heat of the vacuum. When you stand on the surface of the Earth, you are feeling the temperature of the information horizon beneath your feet. The more massive the planet, the hotter the horizon, and the stronger the pull. But this theory is controversial. It is not accepted by everyone. It is a radical departure from Einstein and Newton. It challenges the idea that space-time is a real, physical thing. In Verlinde's view, space-time itself is emergent. It is not a stage that was there before the actors arrived. Space-time is built by the entanglement of the information. Think of a 3D video game again. The space inside the game only exists because the computer is processing code. If the computer stops processing, the space vanishes. Verlinde is suggesting that our reality is similar. Space is the result of quantum bits talking to each other. If the entanglement stopped, space would dissolve. Gravity is just the resistance we feel when we try to move things around in this generated space. It creates a picture of the universe that is fragile, yet resilient. It suggests that the solid ground beneath you, the empty air above you, and the pull anchoring you are all illusions generated by a deeper, hidden layer of reality. We are ghosts living in a machine made of math. And what about dark energy? That mysterious force pushing the universe apart? Entropic gravity has an answer for that too. In a universe with a horizon, a limit to how far we can see, there is a maximum amount of entropy possible. As the universe expands, it creates more volume, which tries to pull more entropy into existence. This tension might be what we perceive as dark energy. The universe is expanding not because of a push, but because it is trying to fill its capacity for information. It is like a gas expanding to fill a balloon. The universe is inflating because it wants to know more. It wants to encode more data. As you lie there, feeling the blankets draped over you, think about the layers of complexity required just to keep you in bed. You are a biological machine made of cells, made of molecules, made of atoms, made of particles, made of strings, and now perhaps made of bits of information scrambling to find their most comfortable arrangement. The comfort you feel, the settling into the mattress, is a mirror of the universe's desire for comfort. You are relaxing, increasing your entropy, letting go of the energy of the day. And the universe is doing the same thing. Gravity is the cosmos trying to relax. It is the universe trying to settle down into a state of equilibrium. So, do not fight the gravity. Do not fight the heaviness. It is the universe hugging you, trying to bring you closer to the state of maximum rest. You are participating in the great cosmic unwinding. But if gravity is just information processing, does that mean reality is a simulation? If space is generated by code, is there a coder? Or is the code self-generating? Is the universe a brain thinking itself into existence? This path leads us to the edge of science and into the realm of philosophy. But physics keeps pushing us there. Every time we peel back a layer, we find that the solid stuff dissolves into something more abstract. We went from rocks to atoms to wave functions to strings to information. We are dematerializing the universe. Maybe that is the ultimate destination of our journey. To realize that matter is just a dream of the light. To realize that heavy and solid are just user interface experiences for consciousness. For now, though, the illusion is persistent. The bed feels real, the dark feels deep, and the gravity feels constant. Whether it is a curve, a particle, or a statistical tendency, it is holding you safe. It is the anchor that keeps you from floating away into the cold void. Let us appreciate the emergent gravity for a moment. It is a concept that tells us that the whole is greater than the sum of its parts. A single water molecule is not a wave. A single neuron is not a thought. A single bit of information is not gravity. But put them together, and you get oceans, minds, and universes. You are an emergent phenomenon too. You are more than just a collection of atoms. You are a consciousness emerging from the complexity of your brain. You are a song emerging from the strings. You are a feeling emerging from the data. And as an emergent being, you have the power to observe the universe that created you. You are the universe's way of thinking about itself. So, as the entropy of your day increases, as your thoughts scatter and soften into dreams, know that you are following the fundamental law of nature. To rest is to obey the cosmos. To sleep is to align with the flow of time. We have explored the strings and the membranes and the holograms and the entropy. But there is one more place we need to look, one more theory that tries to pixelate reality in a completely different way. A theory that says space is not made of strings, but of loops. Tiny, interlocking loops of geometry woven together like chain mail. This is loop quantum gravity. It is the great rival of string theory. It does not need extra dimensions. It does not need parallel universes. It simply says that space itself is granular. It says that if you zoom in enough, you will find that here and there are not continuous, but discrete steps. Are you ready to see the fabric of space woven thread by thread? Are you ready to look at the knots that tie the universe together? The night is quiet and the loops are waiting. Let us prepare to zoom in one last time to the very structure of the void itself. Have you ever taken a moment to really look at the shirt you're wearing? I mean, truly look at it. If you hold the fabric up to the light and stretch it gently between your fingers, the illusion of a solid color disappears. You see the truth of the material. You see individual threads crossing over and under one another in a repetitive, interlocking pattern. You see the tiny gaps of light peeking through the weave. From across the room, your shirt looks like a continuous smooth sheet of blue or gray. But up close, right against your eye, it is revealed to be a mesh. It is a collection of loops. It is not a solid object. It is a relationship between thousands of tiny strands holding onto each other. Now, I want you to take that image, the image of the woven fabric, the interlocking loops, the tiny gaps of light, and expand it until it covers the entire universe. Imagine that the empty space in your room is not empty at all. Imagine it is not a smooth stage like Einstein thought. Imagine it is not a bubbling soup of geometric foam like the quantum foam theory suggests. Imagine instead that it is a fabric, a literal chainmail of geometry. Imagine that space itself is woven from tiny, finite loops of gravitational field, locked together like the links of a medieval armor, creating the illusion of a smooth world, just as the threads create the illusion of a shirt. This is the vision of loop quantum gravity. It is the great rival to string theory. It is a theory that does not ask for 10 dimensions. It does not ask for parallel universes. It stands firmly in the 4 dimensions we know, 3 of space, 1 of time, and says, we do not need to invent ghost worlds to explain gravity. We just need to look closer at the weave. In this world, space is not a background. Space is not a container. Space is the gravitational field itself, and that field is made of grains. Hello, my fellow traveler. It is Walter, the explorer. We are deep in the night now, and the theories are getting stranger, but also somehow more tangible. We are moving from the abstract strings to the concrete loops. Before we thread the needle of this theory, I have a small favor to ask. I was looking at our flight logs, and I noticed that 73% of the curious souls drifting with us through these cosmic mysteries are not yet subscribed to the channel. It might seem like a small thing, just a little digital nod, but it helps us immensely. It keeps our signal strong in the vast noise of the internet. If you find value in these quiet explorations, please subscribe. It is the best way to say, keep going. Now, let us return to the loom of the universe. Loop quantum gravity starts with a simple, radical idea. You cannot divide space forever. In high school geometry, you learn that a line is a collection of infinite points. You can take a ruler and divide an inch in half, then divide that half in half, and again, and again. In pure mathematics, you can do this forever. You can keep slicing space into smaller and smaller pieces for all eternity, and you will never hit a limit. But loop quantum gravity says, no, mathematics is an ideal. The universe is real. In the real universe, there is a limit. There is a smallest size. There is a pixel of space. If you tried to divide space beyond this limit, you would not find smaller space. You would find nothing. Space stops existing below this scale. This smallest unit of space is incredibly tiny, about a billion times smaller than the nucleus of an atom. But it is there. And these tiny units are not just floating around like dust motes. They are connected. They are linked. Imagine a vast network, like a spider web or a neural network in a brain. The nodes of this web, the points where the lines meet, are the atoms of volume. Each node represents a tiny chunk of space, and the lines connecting them, those are the links. They represent the area separating the chunks. This network is called a spin network. And here is the mind-bending part. This network does not exist inside space. The network is space. There is no background. There is no stage. If you leave the network, you are not in empty space. You are nowhere. You are outside of reality. The only thing that exists is the connection between the nodes. When you move your hand through the air, you are not moving through a smooth nothingness. You are pushing through a sea of these tiny nodes. You are rearranging the graph of the universe. The smoothness you feel is just a blur, because the nodes are so small that your senses gloss over them. It is like running your hand through a bucket of fine sand. It feels like a fluid, but it is actually a billion tiny rocks. Space is sand, not water. And what is gravity in this granular world? Gravity is simply the shape of the web. When mass, like the Earth or your body, sits in this network, it distorts the connections. It changes the way the nodes link to each other. It creates a tension in the mesh. That tension is what we feel as weight. You are being pulled down because the web of space-time is bunched up beneath you, and it wants to untangle. This theory is beautiful because it is minimalist. String theory requires 6 or 7 invisible dimensions that we can never see. That is a heavy price to pay. It feels a bit like magic. Loop quantum gravity says, look around you. You see 3 dimensions. That is all there is. The complexity is not in hidden rooms. The complexity is in the weave itself. But the implications of loop quantum gravity are just as wild as string theory, perhaps even wilder. Because if space is made of discrete chunks, then the history of the universe looks very different. Let us talk about the Big Bang again. In classical physics, if you rewind the clock back to the beginning, everything gets smaller and hotter and denser until you hit time zero. At time zero, the entire universe is crushed into a single point of infinite density. This is called a singularity. And to a physicist, a singularity is a disaster. It means the laws of physics have broken. It means the math has failed. Infinite density is impossible. It is a divide by zero error in the code of reality. Loop quantum gravity fixes this. Remember, in this theory, space has a minimum size. You cannot crush it down to zero. You can crush it down until it hits the Planck scale, the size of the smallest loop. But you cannot go further. The loops resist. They push back. Imagine a sponge. You can squeeze a sponge in your hand. You can make it smaller and smaller, but eventually the material of the sponge touches itself. You cannot squeeze it into nothingness. If you keep squeezing, the sponge pushes back against your hand. It wants to expand. According to loop quantum gravity, this is what happened at the beginning of the universe. The cosmos was contracting. It was getting smaller and smaller, crushed by gravity. But it did not hit a singularity. It hit the sponge limit. The quantum loops of space were packed so tightly together that they developed a repulsive force. They pushed back, and they pushed back hard. So, instead of a big bang from nothing, we had a big bounce. The universe collapsed, hit the bottom, and then bounced outward, expanding into the cosmos we see today. Think about what that means. It means there was a universe before ours, a universe that might have looked very much like this one. It had stars. It had galaxies. Maybe it had people lying in beds, wondering about gravity. That universe lived its life, grew old, and then began to collapse. It fell in on itself, shrinking, heating up, until it was compressed into a quantum fireball. And then, bounce. Our universe was born from the ashes of the old one. You are not the first. You are part of an eternal chain of breathing universes, expanding and contracting, inhaling and exhaling. The Big Bang was just the moment of inhalation. It takes away the mystery of creation and replaces it with the majesty of continuity. We are an echo of a previous eon. This idea of the big bounce is one of the most hopeful predictions of loop quantum gravity. It removes the impossible singularity and replaces it with a physical process. It tells us that the universe is resilient. It cannot be destroyed. It can only be reborn. But there is another prediction of loop quantum gravity that is far more unsettling. It has to do with time. We have been talking about space, the nodes, the links, the mesh. But what about the clock ticking on your wall? What about the beating of your heart? In general relativity, time is a dimension. It is the fourth thread in the weave. But in loop quantum gravity, when you look at the fundamental equations, the math that describes the spin networks, the variable for time disappears. It vanishes. The symbol T that we use in almost every physics equation just drops out. What does that mean? It means that at the fundamental level, time might not exist. Time might be an illusion. It might be an emergent property, just like heat or pressure. Imagine a deck of cards. If the cards are shuffled, we say the deck is in a state of disorder. If we sort them by suit and number, we say they are ordered. We perceive a flow from order to disorder. But the cards themselves do not change. An ace of spades is always an ace of spades. The flow is just a relationship between the cards. Loop quantum gravity suggests that the universe is like that deck of cards. The spin network changes. The nodes reconnect. The loops twist. We see these changes and our brains stitch them together into a story. We say, this happened, then that happened. We create the sensation of time flowing, but in reality, there is just the network. There is just the now, rearranging itself forever. There is no great river of time carrying us from the past to the future. There is only the shifting of the grains of space. Time is the measure of change, not a container for it. If nothing changed, if the loops stopped switching links, time would stop. This is a terrifying and liberating thought. It means that the past is not gone, and the future is not waiting. They are just different configurations of the same eternal mesh. You are not running out of time, because time is not a thing you can run out of. You are simply moving through the possible shapes of the universe. So, lie back and feel the mesh holding you. Visualize the tiny loops of gravity passing through your body. They are knitting your atoms together. They are knitting you to the earth. They are knitting the earth to the sun. It is all one giant, continuous textile. You are not a separate object placed into the universe. You are a pattern in the universe. You are a knot in the weave. The same loops that make up the empty space in the corner of your room are twisted tightly to form the protons in your heart. You are made of space. You are made of gravity. When you feel heavy, you are feeling the tension of your own connection to the fabric. You are pulling on the universe, and the universe is pulling back. It is a handshake. It is a hug. The rivalry between string theory and loop quantum gravity is fierce. Physicists argue passionately about which one is right. Is the world made of vibrating strings in 11 dimensions? Or is it made of interlocking loops in 4 dimensions? Or is it something else entirely? We do not know yet. We are still looking for the proof. We are looking for tiny primordial black holes that might have been created in the Big Bounce. We are looking for slight delays in light traveling from distant galaxies, which would prove that space is granular, like a car slowing down on a bumpy road versus a smooth highway. But whichever theory wins, the lesson is the same. Reality is not what it looks like. The smooth, solid, reliable world of our senses is a mask. Behind the mask, there is a mechanism of breathtaking complexity and beauty. And you are part of that mechanism. You are not an observer. You are the fabric itself, waking up and asking questions. But as we dissolve the solid world into loops and strings, we have to ask about the most mysterious entity of all, the one thing that seems to break all the rules, the place where gravity is so strong that even light cannot escape, and where quantum mechanics and relativity crash into each other with the most violence. The black hole. We have touched on them before, but now we must dive in. What is a black hole, really? Is it a hole in the fabric? Is it a dense ball of strings? Is it a fuzzball? Is it a portal? And most importantly, What would happen if you fell in? Would you be crushed, or would you simply float into a new reality? The gravity of the black hole is calling us. It is the ultimate test of all our theories. It is the dark mirror of the universe. Let us drift toward the event horizon. Let us see what lies on the other side of the dark. Have you ever stood at the edge of a deep, dark well and dropped a stone into the abyss? You lean over the mossy rim, listening intently, waiting for the splash that tells you the stone has hit the water. It is a primal feeling, gazing into a hole. It triggers a specific kind of fear in the human brain, the fear of falling, the fear of the dark, and most of all, the fear of the bottomless. A hole is an interruption in the world. It is a place where the solid ground fails. It is a place where here becomes gone. We are terrified of holes because they represent the unknown, the void where our control vanishes. Now, imagine a hole so deep that the stone never hits the bottom. Imagine a hole so dark that even light, the fastest thing in the universe, cannot climb back out to tell you what it saw. Imagine a hole that does not just swallow stones, but swallows time, swallows space, and swallows the very laws of physics. This is the black hole. It is the monster in the closet of astronomy. It is the place where gravity goes mad. For 100 years, we have pictured it as a cosmic drain, a puncture in the fabric of space-time leading to a singularity, a point of infinite destruction. But what if I told you that this picture is wrong? What if I told you that there is no hole? What if the darkest, scariest object in the universe is actually a solid ball of fluff? What if, instead of falling into an endless void, you would land gently on a surface made of vibrating strings, like a beetle landing on a fuzzy woolen sweater? This is the fuzzball theory. It is one of the most comforting and bizarre predictions of string theory. It suggests that gravity does not destroy you. It unravels you and weaves you into a new kind of star. Hello, my brave explorer. It is Walter, the explorer. We have arrived at the event horizon of our journey, the point of no return, where the gravity is strongest and the mysteries are deepest. I am so glad you are still holding my hand as we peer into the abyss. Before we jump, I have a small request. I see that 73% of the wonderful people listening to this story are traveling without a ticket. You haven't subscribed to the channel yet. It is a small thing, a tiny quantum fluctuation of your finger, but it helps us keep this ship flying through the algorithm. If you want to support these voyages into the unknown, please subscribe. It means more than you know. Now, let us look into the dark. To understand why the fuzzball is such a revolutionary idea, we have to look at the paradox that Stephen Hawking gave us. Remember, Hawking proved that black holes evaporate. They leak radiation and eventually disappear. But quantum mechanics has a golden rule. Information is immortal. You cannot delete the universe's data. If you burn a book, the information is in the smoke and ash. If you smash a hard drive, the magnetic patterns are still there in the shards. But if a black hole evaporates, where does the information go? If the black hole was just empty space leading to a singularity, the information would have nowhere to sit. It would be squeezed out of existence. This is the information paradox. It is a war between gravity, which says things can be destroyed, and quantum mechanics, which says they cannot. For 40 years, physicists lost sleep over this. They thought maybe physics was broken. But then came string theory with a radical solution. String theory says, the mistake you are making is thinking that the black hole is empty. In Einstein's classical view, A black hole is mostly empty space. All the mass is crushed into a tiny dot at the center, the singularity. The rest is just a danger zone, bounded by the event horizon. If you crossed the horizon, you wouldn't feel anything special at first. You would just float in the dark until you hit the center and got spaghettified. The fuzzball theory says, no, there is no singularity. There is no empty space. When a giant star collapses, the gravity gets so intense that the strings, the tiny vibrating loops we talked about earlier, stop behaving like particles. They get crushed together. They get tangled. They expand. Imagine a ball of yarn. If you pull on the loose threads, it gets bigger and fluffier. The strings in a collapsing star phase transition into a giant, tangled, vibrating ball of strings. This ball grows until it reaches the size of the event horizon. So, the black hole is not empty. It is full. It is a solid object. It is a planet made of strings. It is a fuzzball. If this is true, the event horizon is not a scary point of no return. It is just the surface of the fuzzball. It is a physical boundary, like the surface of the Earth or the surface of the Sun. But it is a surface made of the most fundamental stuff in the universe. It is a horizon of pure quantum vibration. Now, imagine falling into a fuzzball. In the old story, you would fall through the horizon without noticing, only to be torn apart later. In the fuzzball story, something beautiful happens. As you approach the horizon, the gravity of the fuzzball begins to pull on the strings that make up your body. Remember, you are made of strings too. When you touch the surface of the fuzzball, your strings snap. They unravel. They merge with the strings of the fuzzball. You do not die in the traditional sense. You are not crushed into nothingness. You are translated. Your data, your pattern, the music of your body is absorbed into the orchestra of the fuzzball. You become a vibration on the surface of the dark star. This solves the paradox. Where is the information? It is right there. It is on the surface. The fuzzball is like a giant library of everything that has ever fallen into it. The strings vibrate with the memories of consumed stars, planets, and astronauts. And when the black hole evaporates via Hawking radiation, it carries that information back out into the universe. The fuzzball remembers you. It creates a picture of black holes not as monsters, but as archives. They are the hard drives of the cosmos. They are storing the history of the galaxy in a format of tangled strings. They are fuzzy, shimmering, dark spheres of pure memory. But wait, there is a rival theory, a darker, more violent theory. Some physicists trying to solve the same paradox came up with the firewall hypothesis. They argued that to save quantum mechanics, the event horizon must be a place of extreme energy. They calculated that if you tried to cross the horizon, you would not float through, and you would not gently merge with a fuzzball. You would hit a wall of fire, literally. A wall of high-energy particles that would incinerate you in a nanosecond. The firewall. It is a terrifying image. It turns the black hole into a cosmic furnace. It saves the math, but at a terrible cost. It destroys the smoothness of space. Einstein said space should be smooth. A firewall is a jagged scar in the fabric of reality. So, we have a choice. Is the black hole a fuzzy ball of strings that gently absorbs our song? Or is it a wall of fire that burns us to ash? Or is it something else entirely? Let us turn to loop quantum gravity for a third opinion. Remember the loops? The tiny grains of space? Loop quantum gravity has its own beautiful solution to the black hole problem. It is called the Planck star. In this theory, when a star collapses, it crushes down until it hits the smallest possible size of space, the quantum loop limit. It cannot get any smaller. It cannot become a singularity. So, what does it do? It bounces, just like the universe bounced in the Big Bounce. The star inside the black hole bounces. It collapses, hits the bottom, and then explodes outward. A black hole is actually a star that is exploding. But Walter, you might ask, if it is exploding, why does it look black? Why doesn't it shine? Here is the magic of gravity, time dilation. Gravity slows down time. Near the center of a black hole, gravity is so strong that time almost stops. To the star itself, the bounce takes a fraction of a second. It falls in, hits the bottom, and bounces out. Boom! But to us, watching from the outside, millions of light years away, that fraction of a second is stretched out over billions of years. We are watching a movie in extreme slow motion. We are seeing a star that is in the middle of exploding, but the explosion is taking the lifespan of the universe to happen. A black hole is not a static object. It is a process. It is a star holding its breath for an eon before it exhales. This is the Planck star theory. Inside the dark shell of the event horizon, there is a tiny, dense, white-hot core of quantum space that is trying to get out. It is waiting. And eventually, when the black hole evaporates enough, the time dilation will weaken, and the star will finally finish its explosion. It will burst open, releasing everything it swallowed. This means that information is never lost here either. It is just delayed. If you fell into a Planck star black hole, you would fall toward the center, join the bounce, and then, billions of years later, by outside clocks, you would be spewed back out into the universe. You are a time traveler. You are taking a shortcut through the end of time. Which version do you prefer? The fuzzball, where you are woven into a tapestry of strings? The firewall, where you are returned to pure energy? Or the Planck star, where you are held in suspended animation inside a slow-motion explosion? All of these theories tell us the same deep truth. Gravity is not just a force that pulls. It is a force that transforms. It changes the nature of matter. It changes the flow of time. It changes the structure of information. Gravity is the great alchemist. It takes the lead of dying stars and turns it into the gold of quantum geometry. It takes the chaos of the void and turns it into the archives of the fuzzball. And think about the scale. A black hole can have the mass of 1 billion suns. That is 1 billion stars, 1 billion systems, maybe billions of planets, all crushed together. In the fuzzball picture, all that complexity is still there, tangled in the strings. The black hole is the most complex object in the universe. It is a single object with more parts than a galaxy. This brings us back to the holographic principle. If the fuzzball is real, then the surface of the black hole really is a hologram of everything inside. The strings on the surface are the data. The interior is just the projection. Falling into a black hole might be like stepping through the screen of a movie and becoming the film itself. You leave the illusion of 3D space and return to the reality of 2D information. You go home to the source code. There is a strange peace in this idea. We spend our lives terrified of disappearance. We fear death because we fear the loss of us. We fear that our memories, our love, our consciousness will simply vanish like smoke. But physics is shouting as loud as it can with its equations that disappearance is impossible. The universe does not allow deletion. It is a conservationist. It hoards every bit of data. It keeps every photon. It remembers every wave. Even in the belly of the ultimate monster, the black hole, the information is safe. It is woven. It is stored. It is bouncing. You are written into the ledger of the cosmos in permanent ink. Gravity ensures it. The heaviness you feel in your bed is the same force that preserves the memory of stars. It is the binding agent of reality. So, as you drift in the quiet of your room, imagine the black holes scattered across the night sky. Do not see them as holes. See them as jewels, dark, heavy jewels made of compressed space and time. See them as the anchors that hold the galaxy together. See them as the libraries where the universe keeps its secrets. And remember the fuzzball. Imagine that space is soft. Imagine that if you fell far enough, you wouldn't hit a wall. You would land in a nest of vibrating strings, humming the song of everything that has ever been. We are nearing the end of our journey into the nature of gravity. We have looked at the particles, the waves, the strings, the loops, and the holograms. We have seen gravity as a force, a curve, a statistic, and a memory. But there is one final question, a question that brings it all back to you. If gravity is the connection between all things, and if you are conscious, does your consciousness have gravity? Does the mind pull on the universe? Is the observer just a passive watcher? Or are we the ones creating the gravity by looking? We are going to take the final step. We are going to look at the quantum mind. We are going to ask if the universe exists because you are here to feel it. We are going to close the loop between the physics of the stars and the physics of the soul. The night is almost over. The dawn is coming. But before the sun rises, let us ask the ultimate question. Who is the dreamer? Have you ever stood in front of a mirror in a dimly lit room and just stared into your own eyes? If you hold your gaze long enough, something strange happens. The edges of your face begin to blur. The familiar features, the nose you have known all your life, the curve of your lips, start to dissolve or distort. For a fleeting second, you might feel a sudden jolt of dissociation, a weird, quiet panic that the person looking back at you is not you, but a stranger. Or worse, that there is no one behind those eyes at all. It is a terrifying sensation, but it reveals a profound truth about the nature of our existence. Looking is not a passive act. When you look at the world, you are not just a camera recording a scene that is already there. You are an active participant. Your gaze interacts with the light. Your brain processes the signals. Your consciousness constructs the image. To look is to touch. To look is to build. To look is to decide. But how deep does this rabbit hole go? Does the world exist before you look at it? If you were not there to stare into the mirror, would your reflection still be hovering in the glass? Or would the photon simply scatter into the void, unseen and unformed? This is the most famous question in quantum mechanics. Does the moon exist when no one is looking? And for nearly a century, physicists have been forced to whisper a terrifying answer. Maybe not. Or at least, not in the way you think. Without an observer, the moon might just be a probability, a wave of potential, a ghost. But what if the observer is not you? What if the observer is gravity itself? What if the force that pulls you to your bed is the same force that collapses the ghostly waves of probability into the solid reality of your room? What if gravity is the engine of consciousness? This is the quantum mind hypothesis. It is the bridge between the physics of the stars and the physics of the soul. It suggests that you are not just a biological machine made of meat and electricity. You are a gravitational event. You are a ripple in space-time that has become aware of itself. Hello, my fellow observer. It is Walter, the explorer. We have traveled from the smooth curves of relativity to the jagged loops of quantum gravity. And now we stand at the precipice of the mind. We are about to look into the mirror of the universe and ask if it is looking back. Before we step through the looking glass, I have a small favor to ask. I see that 73% of the conscious minds drifting with us tonight have not yet subscribed to the channel. It is a small action, a mere collapse of a wave function, but it anchors our community in this vast digital ocean. If you want to keep exploring the boundaries of what is possible, please subscribe. It helps us keep the signal clear. Now, let us return to the question of the observer. To understand why gravity might be the secret of consciousness, we have to go back to the experiment that broke reality. The double-slit experiment. You have probably heard of it, but let us visualize it together. Imagine you have a wall with two vertical slits cut into it. Behind that wall is a screen. Now, imagine you have a gun that shoots tiny marbles, particles of matter. You fire the marbles at the wall. Some go through the left slit. Some go through the right slit. On the back screen, you get two bands of marks. Simple, logical. Matter behaves like matter. Now, we shrink the marbles down to electrons. We fire them one by one. Logic says we should still get two bands, but we don't. We get a pattern of many bands, an interference pattern. This is the pattern you get when waves ripple through the slits and crash into each other. It means the electron did not go through the left slit or the right slit. It went through both slits at the same time. It behaved like a wave. It was in a superposition of states. It was a ghost. But here is the twist. If you put a detector, a camera, a sensor, an eye, next to the slits to see which one the electron actually goes through, the wave vanishes. The electron suddenly snaps back into behaving like a marble. It goes through just one slit. The interference pattern disappears. The act of looking changed the outcome. The measurement forced the universe to decide. This is the measurement problem. It implies that the universe remains in a fuzzy, undecided dream state until something observes it. This bothered Albert Einstein immensely. He hated it. He said, "I like to think the moon is there, even if I am not looking at it." But the math of quantum mechanics disagrees. The math says the moon is a wave function until it interacts with something. For decades, physicists argued about what constitutes an observer. Does it have to be a human, a cat, a camera, a particle of air? The debate was stuck. It was a philosophical deadlock. Enter Sir Roger Penrose, one of the greatest mathematical physicists of our time, the man who worked with Stephen Hawking on black holes. Penrose looked at this problem and said, "We are missing something. We are missing gravity." Penrose realized that every object has mass, and every mass curves space-time. If a particle is in a superposition, if it is in two places at once, then its gravitational field must also be in two places at once. Imagine a tiny pebble. If it is in a quantum superposition of being here and there, then the fabric of space-time around it is being curved in two different ways simultaneously. You have a superposition of two different geometries. But Penrose argued that space-time is stiff. It is rigid. It does not like to be torn apart. It can handle a tiny superposition for a tiny particle like an electron. But as you get bigger, the energy difference between the two curves becomes too great. The universe cannot sustain the separation. It becomes unstable. Eventually, the universe says, "Enough," and it snaps. It forces the object to choose one location. It collapses the superposition. Penrose called this objective reduction. It is objective because it does not depend on a human looking at it. The universe observes itself through gravity. Gravity is the limit of the dream. Gravity is the sharp edge of reality. So, a rock does not need you to look at it to be solid. Its own gravity is strong enough to collapse its wave function constantly. The rock is observing itself billions of times a second. But an electron? Its gravity is so weak that it can stay in dream mode for a long time. Now, here is where it gets truly wild. Penrose asked, "What does this collapse feel like?" When the universe snaps from a fuzzy wave of possibilities into a single, concrete moment of now. What is that? He proposed that every time this gravitational collapse happens, a tiny spark of proto-consciousness is released. A moment of awareness, a blip of being. For a rock, these blips are random and chaotic. It has no mind. But what if you could organize these blips? What if you could build a machine that isolates a quantum system, protects it from the noise of the environment, lets it evolve into a massive superposition, and then orchestrates the collapse? What if you could synchronize millions of these gravitational snaps into a unified rhythm? You would have a consciousness. You would have a mind. And Penrose, along with anesthesiologist Stuart Hameroff, suggested that this machine already exists. It is inside your head. It is your brain. Specifically, it is the microtubules inside your neurons. Microtubules are tiny tube-like structures that act as the scaffolding for your cells. For years, biologists thought they were just structural, like the skeleton of the cell. But Penrose and Hameroff argued that they are actually quantum computers. They act as Faraday cages for quantum states, shielding the electrons inside from the noisy environment of the brain. Inside these tubes, electrons can enter a superposition. They can exist in multiple states at once. The space-time geometry inside your neuron splits. It curves in multiple ways. The tension builds, the gravity pulls, and then, snap, the wave function collapses. A moment of conscious awareness occurs. Your brain is doing this 40 times a second, or maybe more. Your stream of consciousness, the feeling of I am, is actually a rapid-fire sequence of gravitational collapses. You are a symphony of space-time snapping into place. Think about what this means. It means that consciousness is not a computation. It is not just neurons firing electrical signals like a computer. A computer is logical. It follows rules. But a quantum collapse is non-computable. It involves a choice that comes from the fundamental geometry of the universe. This is why computers might never be truly conscious, and why you are. You are tapping into the fundamental creativity of the cosmos. It also means that your mind is intrinsic to the universe. You're not an accident. If consciousness is caused by gravity, then consciousness is as fundamental as mass or energy. It is baked into the physics. The universe is built to be aware. When you lie in bed and feel your weight, you are feeling the very mechanism that makes you conscious. The gravity pulling you down is the same force that is knitting your moments of awareness together. You are a gravity receiver. You are an antenna tuned to the curvature of space-time. This connects us back to the black holes and the Big Bang. If black holes are the ultimate gravitational objects, are they also the ultimate conscious entities? Is a black hole, with its immense gravity constantly collapsing wave functions, a giant mind? Some physicists have flirted with the idea of panpsychism, the idea that the universe itself is awake. If Penrose is right, then the boundary between mind and matter is erased. Matter is mind, frozen into place by gravity, and mind is matter in its quantum, fluid state just before it freezes. Imagine your brain as a tiny universe. Inside your neurons, Little pockets of space-time are bubbling and curving, exploring different futures, different thoughts, different choices. Then gravity steps in and selects one. That selection is your thought. That selection is your will. You are deciding the future of the universe, one quantum collapse at a time. This theory, called OR, Orchestrated Objective Reduction, is controversial. Critics say the brain is too warm and wet for quantum states to survive. They say the decoherence, the noise, would destroy the superposition before gravity could act. But recent discoveries in biology suggest that life does use quantum mechanics. Photosynthesis uses quantum coherence to harvest light. Birds use quantum entanglement to navigate by the Earth's magnetic field. Why wouldn't the brain use the most powerful tool in nature's toolbox? So, as you drift toward sleep, consider this. Your transition from wakefulness to dreams, there might be a change in the quantum state of your brain. As you lose focus, the orchestrated collapses might soften. The rhythm might change. You drift back into the wave function. In dreams, you are less bound by the rigid laws of reality, because your gravity machine is running in a different mode. You are returning to the superposition. You are becoming a wave again. And what about death? If consciousness is a fundamental property of space-time geometry, does it end when the biological machine stops? Or does the quantum information, the pattern of the strings, the loops, the geometry, simply return to the universe? Remember the conservation of information. Remember the holographic principle. Nothing is lost. Maybe the you that observes is just a localized vortex in a universal ocean of proto-consciousness. When the vortex dissipates, the water remains. The awareness returns to the bulk. The quantum mind hypothesis is a beautiful, vertigo-inducing idea. It tells us that we are not strangers in the universe. We are not ghosts in a machine. We are the machine itself, waking up. We are the universe observing itself through the lens of gravity. Every time you look at the moon, you are helping to keep it there. Every time you make a choice, you are collapsing a universe of possibilities into a single reality. You are a powerful creator. You are a collapse engine. Feel the weight of your body again. That sensation is the hum of the engine. It is the vibration of the connection between your mind and the fabric of space-time. You are heavy because you are real. You are heavy because you are here. And as we close this chapter on the mind, we have to ask, if we are all connected by gravity, and gravity connects all the dimensions, and dimensions connect all the universes, are we all just one mind? Are we all just one observer, looking out through billions of different eyes? The physics of unity, the physics of the one. This is where the science meets the mystical, and it is where we will go next. We will explore the idea of the entangled universe. We will look at how particles separated by billions of light years can communicate instantly. We will ask if separation is the biggest illusion of all. If two particles interact once, they are entangled forever. They share a wave function. They share a destiny. You have interacted with the earth. You have interacted with the sun. You have interacted with the air. You are entangled with everything. So sleep well, my entangled friend. You are not alone in the dark. You are connected to every star, every black hole, every atom in the cosmos. The web of gravity holds you tight, not just to your bed, but to the heart of everything that exists. We are almost at the end of our journey. The final chapter awaits. A chapter on the ultimate fate of gravity and the ultimate fate of you. Will gravity eventually crush the universe back into a singularity? Or will it tear it apart in a big rip? Or will we fade gently into the night? The future is a wave function waiting to collapse. Let us go see what it holds. Have you ever had the sensation, perhaps with a sibling or a very close friend, that you knew exactly what they were thinking before they even opened their mouths? It is a fleeting moment of perfect synchronization. You are in one room, they are in another, or perhaps they are miles away in a different city, and yet you feel a sudden, undeniable tug of connection. You pick up the phone to call them, and they are already calling you. You feel a sudden pang of worry, and you find out later that they were in trouble at that exact moment. We call this intuition. We call it coincidence. We dismiss it as a trick of memory or a statistical anomaly. We tell ourselves that minds are separate islands, locked inside the bone cages of our skulls, unable to touch without words or signals. But what if I told you that this feeling of connection is not magic, and it is not a coincidence? What if it is a macroscopic echo of the most fundamental law in the universe? What if I told you that separation is the greatest delusion ever created by the cosmos? What if physics has proven, beyond a shadow of a doubt, that two objects can be physically separated by billions of light years and yet remain, in a very real sense, the exact same object? This is the phenomenon of quantum entanglement. Albert Einstein called it spooky action at a distance. He hated it. He refused to believe it was real because it violated everything he knew about space and time. It suggested that information could travel faster than light. It suggested that space, the vast empty gulf between stars, was not a barrier at all. But Einstein was wrong. Entanglement is real. It is the glue of reality. And tonight, we are going to explore the terrifying and beautiful possibility that gravity itself, the force holding you to your bed, is nothing more than the tension of billions of invisible threads connecting you to the rest of the universe. Shutterstock. Hello, my fellow entangled soul. It is Walter, the explorer. We have journeyed through the illusion of smoothness, the vibration of strings, and the hologram of the horizon. Now, we are diving into the web of connection that binds it all together. Before we trace these invisible lines, I have a small favor to ask. I was checking our communication logs, and I see that 73% of the wonderful travelers listening to this frequency have not yet subscribed to the channel. It is a small gesture, a simple click, but it entangles our paths in a way that helps this channel grow and reach other lonely explorers in the dark. If you find comfort in these stories, please subscribe. It keeps the signal strong. Now, let us return to the spooky action. To understand why entanglement is so mind-bending, imagine you have a special coin. You slice this coin in half, edgewise, so you have a head's half and a tail's half. You put each half in a separate envelope. You keep one envelope, and you give the other to a friend who travels to the other side of the galaxy, to a planet orbiting the star Proxima Centauri. Now, you open your envelope. You see heads. Instantly, without a single second of delay, you know for a fact that your friend on Proxima Centauri has tails. This seems normal, right? The coins were already set before your friend left. The information was hidden in the envelope the whole time. This is called classical correlation. It is like having a pair of gloves. If you find the left one, you know the right one is somewhere else. There is no mystery here. But in the quantum world, particles like electrons do not have a fixed state until you look at them. They are not heads or tails while they are in the envelope. They are a spinning cloud of probability. They are both and neither. They are a wave function. When two particles interact and then separate, they become entangled. They share a single wave function. They become one mathematical object stretching across space. If you send one electron to Proxima Centauri and keep one on Earth, they are still spinning in a blur of uncertainty. But the moment, the exact nanosecond, you measure your electron on Earth and force it to decide to be up, heads, the electron on Proxima Centauri instantly forces itself to be down, tails. It does not matter if they are light years apart. The decision happens instantaneously. It happens faster than light. It is as if the space between them does not exist. It is as if they are right next to each other. This is what terrified Einstein. He believed that nothing could go faster than light. He believed that for point A to affect point B, a signal had to travel across the space between them. Entanglement says, no, there is no travel. There is only connection. For decades, physicists tried to find a loophole. They tried to prove that there were hidden variables, secret instructions inside the particles that told them what to do. But in the 1960s, a physicist named John Bell came up with a mathematical test to check this. And in the decades since, experiment after experiment has proven Bell right and Einstein wrong. There are no hidden variables. The connection is real. The universe is non-local. This means that distance is not what we think it is. We think distance is a physical separation that isolates objects. But if two things are entangled, distance is irrelevant. They are intimately touching, regardless of how many miles lie between them. Now, let us bring gravity back into the picture. For a long time, physicists thought entanglement was just a weird quirk of quantum mechanics, something that happened to tiny particles but had nothing to do with the heavy, curved space-time of gravity. They were wrong. In the last 10 years, a revolutionary new idea has emerged, championed by physicists like Juan Maldacena and Leonard Susskind. It is an equation that looks like a Zen koan, ER. EPR. ER stands for Einstein-Rosen bridge. This is the technical name for a wormhole. You have seen them in science fiction movies, shortcuts through space that let spaceships travel instantly from one galaxy to another. Einstein and his colleague Nathan Rosen discovered them in the math of general relativity back in 1935. They are tunnels through the fabric of space-time. EPR stands for Einstein-Podolsky-Rosen. This refers to the paper that described quantum entanglement. It is the spooky action. So, the equation says, wormholes grant entanglement. Think about what that means. It suggests that they are the same thing. It suggests that when two particles are entangled, they are actually connected by a tiny, microscopic wormhole, a thread of space-time geometry that stitches them together. When you entangle two electrons, you are literally building a bridge in space-time. You are creating a tunnel. The reason the electron on Proxima Centauri knows what the electron on Earth is doing is not because a signal traveled faster than light. It is because they are touching through a wormhole. The long way around through normal space is 4 light years, but the shortcut through the wormhole is 0 distance. Now, expand this. Imagine that space is not empty. Imagine that the vacuum is filled with pairs of virtual particles constantly popping in and out of existence, entangling with each other, and then vanishing. This is happening everywhere, all the time. The vacuum is a frothing soup of entanglement. If EPR is true, then every single one of these entanglements is a tiny wormhole, the fabric of space The very geometry that you're moving through is sewn together by billions upon trillions of these micro wormholes. Space is not a smooth sheet. It is a quilt. It is a mesh of tunnels. And gravity? Gravity is the tension of this mesh. Gravity is what happens when you try to pull the quilt apart. When you separate two entangled objects, you are stretching the wormhole connecting them. That stretching requires energy. That resistance is what we might perceive as the structure of space-time itself. This leads to a breathtaking conclusion. Space-time is not a fundamental stage. Space-time is built out of entanglement. Without quantum entanglement, there would be no here and there. The universe would just be a disconnected dust of points with no relationship to each other. Entanglement is the weaver. It knits the points together into a smooth, continuous blanket. So, when you lie in bed and feel the gravity of the earth, you are feeling the result of a massive cosmic entanglement. The particles in your body are entangled with the particles in the earth. The particles in the earth are entangled with the particles in the sun. The web extends outward, thread by thread, wormhole by wormhole, stitching the galaxy into a coherent whole. You are not just on the earth. You are woven into it. You are connected to it by tunnels of geometry that bypass the illusion of empty space. And this brings us to a profound philosophical question. If the universe started with a Big Bang, a single point, where all matter and energy was crushed together, then everything in the universe was once in contact. Everything was once entangled. As the universe expanded, the particles flew apart. They formed stars, galaxies, planets, and people. But in the quantum world, entanglement never truly breaks unless you deliberately disturb it. This means that, deep down, the entanglement from the Big Bang might still be there. The atoms in your left hand might be entangled with atoms in a star 1 billion light years away. The electrons in your brain might be entangled with the dust of a nebula in the Andromeda galaxy. We are simply the scattered fragments of a single original object. The separation we see, the vast distances, the empty voids, is a surface-level illusion. Beneath the surface, the wormholes are holding us all in a tight embrace. We are one, not in a metaphorical, poetic sense, but in a rigorous, physical, geometric sense. The universe is a single, self-entangled entity. This might explain why the universe seems so finely tuned, why the laws of physics are the same everywhere, why the temperature of the cosmic background radiation is so uniform. It is because the universe is talking to itself. It is constantly whispering through the wormholes, keeping every part in sync with every other part. Imagine for a moment that you could see these connections. Close your eyes and visualize the room around you. If you had quantum eyes, the walls would dissolve, the air would dissolve. Instead, you would see a blindingly complex web of glowing filaments, threads of light connecting your skin to the sheets, threads connecting the sheets to the mattress, threads connecting the mattress to the floor, to the foundation, to the magma of the earth, and shooting out from your body, going through the roof, going through the sky, are threads reaching to the moon, to the sun, to the distant quasars. You are a hub of connection. You are a knot in the golden web of Indra. Every breath you take vibrates the web. Every thought you think ripples through the wormholes. You are not isolated. Loneliness is a lie, told by the limitations of your eyes. In the language of gravity and entanglement, you are never, ever alone. But what happens if you break the entanglement? What happens if you cut the threads? Physicists have asked this question, specifically regarding black holes. We talked about the firewall paradox earlier, the idea that a wall of fire might exist at the event horizon. This paradox arises from asking what happens to the entanglement of particles falling into the hole. If you break the entanglement between the inside of the black hole and the outside, you are effectively snapping the wormholes. You are ripping space-time. And when you rip space-time, energy is released. Violent, hot, destructive energy. This is the firewall. It suggests that space-time is fragile. It relies on the constant maintenance of these quantum connections. If the entanglement were to stop, space would disintegrate. The universe would shatter into non-spatial dust. This gives a whole new meaning to the word integrity. The integrity of the universe, its wholeness, its continuity, depends on relationship. It depends on particles knowing each other. Without that knowledge, without that spooky action, reality falls apart. So, your feeling of safety, your feeling of the solid ground, is a testament to the strength of these bonds. The universe is holding itself together with a grip that is stronger than steel, stronger than gravity, stronger than time. It is the grip of quantum love. I use the word love carefully, but think about it. What is love in the human experience, if not a denial of separation? What is it, if not the feeling that another person is part of you, that their happiness is your happiness, that their pain is your pain? When you love someone, you feel entangled. You feel that distance cannot truly separate you. Maybe human love is just the biological evolution of quantum entanglement. Maybe our brains, those quantum machines we talked about in the last chapter, are wired to recognize and prioritize these deep, fundamental connections. Maybe when you miss someone, you are physically feeling the tension of the wormholes stretching between you. It is a beautiful thought to drift to sleep with, that the emotional connections you value most are mirrored by the physical laws of the cosmos, that the universe is built on the principle of connection. And as you lie there, consider the future. If we can master this entanglement, if we can understand how to manipulate the ER-EPR bridges, what becomes possible? Could we open the wormholes? Could we step through them? Could we build a quantum internet that communicates instantly across the galaxy? We are already trying. Scientists are building quantum satellites today. They are teleporting particles from the ground to orbit. We are taking the first baby steps into the entangled future, a future where goodbye doesn't mean gone, a future where distance is a choice, not a prison. But there is a dark side to this web. If everything is connected, then everything affects everything else. Chaos in one corner of the universe ripples to another. We are vulnerable to the vibrations of the whole. And this brings us to the ultimate question of destiny. If the universe is a single entangled block, is the future already written? In the quantum world, things are probabilistic until measured. But if the universe observes itself, if the web is constantly collapsing its own wave functions, is there room for free will? Or are we just sliding down the threads of a tapestry that was woven at the beginning of time? We have looked at the web, we have seen the wormholes, we have felt the unity. But now we must look at the end of the story. If gravity creates space-time, can it also destroy it? What is the final fate of this entangled masterpiece? Will the web rip? Will it freeze? Or will it loop back on itself? In the next chapter, we will face the big rip and the heat death. We will ask what happens when the entanglement finally fades. But do not fear, for in a quantum universe, the end is never really the end. It is just another change of state. Sleep now in the comfort of the web. Let the wormholes cradle you. Let the spooky action keep you safe. You are everywhere. You are everyone. You are home. Have you ever stayed awake until the very end of a party? The music has stopped. The guests have all gone home. The lights are turned up, revealing the empty cups and the confetti on the floor. There is a specific kind of silence that falls over a room that was just full of life. It is not a scary silence. It is a tired silence. It is the silence of completion. You look around, and you know that something has ended. But you also know that the morning will come. You know that the mess will be cleaned up. You know that the house will be ready for another day. But what if the party never starts again? What if the silence stretches on forever? This is the question that haunts the ultimate future of our cosmos. We have spent this entire journey talking about what gravity is: a force, a curve, a string, a loop, a hologram, a web. But we haven't talked about what gravity will do in the end. Will gravity win the tug of war? Will it pull everything back together into a warm, safe embrace? Or will it lose? Will it be defeated by the dark energy pushing the universe apart? Will the web snap? Will the strings break? We are going to travel now to the absolute limit of time. We are going to fast forward past the life of the sun, past the death of the Milky Way, and into the deep, deep dark of the far future. We are going to witness the death of gravity itself. And in that death, we might just find the secret of eternal life. Hello, my timeless friend. It is Walter, the explorer. We have reached the final chapter of our voyage. We have drifted from the bed you are lying in to the edge of the multiverse, and now we stand at the end of time. It has been an honor to guide you through these mysteries. Before we take this final step into the forever, I want to make one last call to the crew. I see that 73% of the Stardust souls listening to this story are still not subscribed to the channel. We are building a library of wonder here, a sanctuary for the curious, and your subscription is the gravity that holds it together. If you have found peace or perspective in these nights we have shared, please click that button. Join us. Let us keep exploring the infinite together. Now let us turn our eyes to the final horizon. To understand the fate of gravity, we have to look at the war that is happening right now in the vacuum of space. It is a silent war between two titans. On one side, we have gravity. Gravity is the builder. It wants to pull things together. It wants to make stars, galaxies, and black holes. It wants to clump the universe into a ball. On the other side, we have dark energy. We don't know what it is, but we know what it does. It pushes, it stretches space. It wants to tear the universe apart. It wants to make the void bigger, colder, and emptier. For billions of years, gravity was winning. It pulled the gas clouds together to form the first stars. It built the galaxies. But about 5 billion years ago, something changed. The universe got too big. The gravity got too dilute. Dark energy took over. It stepped on the gas pedal. Since then, the expansion of the universe has been accelerating. The galaxies are flying away from us faster and faster every second. If this continues, gravity is doomed. We are heading toward a scenario called the Big Freeze, or the Heat Death. It sounds violent, but it is actually a very slow, very gentle fading away. First, in about 100 billion years, the other galaxies will disappear from our view. The space between us and them will be expanding faster than the speed of light. Their light will never reach us again. We will be alone in the dark, thinking our Milky Way, which will have merged with Andromeda, is the entire universe. Then the stars will go out. One by one, the lights will flicker and die. The massive stars will explode. The medium stars, like our sun, will shrink into white dwarfs and then cool into black stones. The red dwarfs, the longest living stars, will burn for trillions of years, but eventually even they will run out of fuel. The universe will be a graveyard of cold rocks and black holes. This is the era of degeneracy. The only light will come from the occasional collision of dead stars. Gravity will still be there, but it will be weak. It will be holding onto corpses, but even the corpses will not last. Protons, the building blocks of atoms, might not be stable forever. Many theories suggest that over immense timescales, numbers so big we don't have names for them, matter itself will decay. The atoms in the dead stars will dissolve into radiation. The rocks will vanish. The dust will vanish. And then only the black holes will remain. The monsters we talked about in the last chapters. They will be the kings of the empty universe. Giant, silent spheres of curved space-time, hoarding the memories of the cosmos. For eons upon eons, they will drift in the absolute dark. But remember Stephen Hawking. Remember that black holes evaporate. Very, very slowly they leak energy. They bleed into the void. Over years, denoted by a 1 followed by 100 zeros, the black holes will shrink. They will give up their mass. And finally, in a blinding flash of gamma rays, the last black hole will pop and vanish. At that moment, gravity will die. There will be no mass left in the universe, no stars, no planets, no black holes, no atoms. There will only be light, just a sea of photons and gravitational waves stretching out into an infinitely expanding, cold, dark void. This is the heat death, maximum entropy, the end of the story. It sounds terrifyingly lonely, doesn't it? It sounds like a tragedy. To think that all the beauty, all the complexity, all the love and the struggle of existence ends in a uniform soup of cold radiation. But wait, there is a twist. Physics is a circle, not a line. And one of the most brilliant minds of our time, Sir Roger Penrose, the man who helped us understand the black hole singularity, has a different idea. The beautiful, hopeful idea called conformal cyclic cosmology. Penrose asks a simple question: what is time to a photon? We experience time because we have mass, we change, we age. Clocks tick because atoms move. But according to relativity, a photon of light does not experience time. From the perspective of light, the moment it is emitted and the moment it is absorbed happen at the exact same instant. Light is timeless. Penrose also asks, what is size to a photon? We know what big and small are because we have rulers made of atoms. We can compare a galaxy to a human. But if all the atoms are gone, if all the mass is gone, and there is nothing but light, the concept of scale disappears. In a universe of pure radiation, there is no difference between a universe that is 1 trillion light-years wide and a universe that is the size of an atom. Big and small lose their meaning. So, in the deep, deep future, when the universe has expanded effectively to infinity and all mass has evaporated, the universe forgets how big it is. It loses track of scale. And here is the magic trick. Mathematically, a universe that is infinitely big, cold, and filled with radiation looks exactly like a universe that is infinitely small, hot, and filled with radiation. The end of the universe looks exactly like the Big Bang. Penrose suggests that the heat death is not the end. It is the transition. The infinite expansion of our eon becomes the singularity of the next eon. The pop of the last black hole is not a death knell. It is the spark of the next creation. We are living in a cycle. We are one breath in an eternal lung. The universe expands dissolves, loses its scale, and then, in a moment of geometric transformation, it becomes the seed for a new Big Bang. This means that gravity is not just a force that pulls things together. It is the bridge between the eons. The gravitational waves from the giant black hole, collisions in our universe might ripple through the transition. They might leave scars or patterns in the next Big Bang. We might be looking at the ghosts of a previous universe right now. When we look at the cosmic microwave background, the afterglow of our Big Bang, we might be seeing the imprint of the supermassive black holes from the universe that existed before ours. We are walking in the footsteps of giants who lived and died before time began for us. And billions of years from now, when our universe dissolves, the gravity of our black holes will imprint a message onto the next universe. The information, the complexity, the story of our reality will be passed on. So, the party never really ends. The guests leave, the lights go up, the house is cleaned, and then the door opens for the next celebration. How does this make you feel as you lie in the dark? Does it make you feel small? Or does it make you feel ancient? The atoms in your body were forged in stars. The gravity holding you down is a ripple from the beginning of time, and the energy that animates your mind will eventually become part of the light that births the next eon. You are not a temporary accident. You are a necessary step in the eternal dance of the cosmos. We have asked, what is gravity made of? We found that it is the curvature of a smooth sheet. We found that it is the exchange of graviton particles. We found that it is the vibration of tiny strings in 10 dimensions. We found that it is the result of leakage from parallel brain worlds. We found that it is a holographic projection from the edge of the universe. We found that it is the entropy of information seeking rest. We found that it is a weave of quantum loops. We found that it is the collapse of the wave function that creates consciousness. We found that it is the tension of wormholes connecting all things. And now, finally, we find that gravity is the memory of the universe. It is the thread that ties the death of one world to the birth of another. Gravity is the patience of nature. It is the force that waits. It waits for the stars to form. It waits for the planets to cool. It waits for life to crawl out of the oceans. It waits for you to lie down and close your eyes. And in the end, it waits for the universe to dissolve so it can start all over again. So, tonight, when you feel that pressure against your back, do not think of it as a weight dragging you down. Think of it as an anchor holding you steady in the river of eternity. You are safe. You are held. You are part of a system that knows exactly what it is doing. The mysteries we have explored are vast. They are confusing. They break our intuition. But they all point to one simple truth. The universe is not a collection of separate dead things. It is a single, dynamic, interconnected, and perhaps even conscious process. You are not in the universe. You are of the universe. You are the universe experiencing itself. You are the gravity feeling its own pull. As you drift off to sleep, let the strings vibrate. Let the loops weave. Let the hologram shimmer. Let the wormholes connect you to the stars. The journey of discovery is an infinite loop. There will always be another question. There will always be another mystery. But for now, the answers can wait. The equations can rest. The night is here. The gravity is here. And you are here. Sleep well, explorer. The universe will still be here when you wake up. And if, 1,000,000,000,000 years from now, it isn't, well, we know that is just the beginning of another adventure. Good night.